Recording in progress.
We are broadcasting and recording.
Okay, thank you, and welcome everyone to the meeting of the Delta Independent Science Board. I'd like to officially call the meeting to order and start off, but as most of you know, we were originally planning to have a two-day meeting, with yesterday being a full day of a field tour and an extended meeting today, do that in person. But due to sort of public health and safety concerns with increasing levels of COVID and increasing restrictions, as well as some travel complications, we've decided to cancel our face-to-face for the August meeting and probably reschedule later in the fall, as we'll talk about later, and conduct this entire meeting via remote access. And in that regard, we will take written questions and comments, and please email your public comments and questions to disb@deltacouncil.ca.gov. And in your request, let us know what item you want to make a public comment on, and if you prefer to do it orally, use the raise hand function or send an email to us. And after you're recognized, then please give us your full name and affiliation before you start your public comment. So I'd like to take a roll call, and please state your board members, please state your full name and whether or not you have any new things to report regarding conflict of interest. Steve Brandt, nothing new here. Tom?
Tom Holzer, nothing new here either.
Joe?
Nothing new.
Lisa?
Lisa Ranger, no new declarations.
Okay, Virginia?
Virginia Dale, no new declaration.
Diane? Diane, I guess, was going to be about 45 minutes late in joining us. So Bob?
Bob Nyman, nothing new here.
And Tanya?
Tanya Heikela, no new declarations.
And Jay Lund has given his apologies. He's on travel and won't be attending these meetings. So let me move on to item number 2, which is the chair's report. And I just have a few things. The first is an update on the status of the water supply reliability review. And that review is currently being prepared for release to the public and a request for a 30-day public comment period. And that should be out relatively shortly. And we will be then discussing that in more detail during our September meeting, but it's not a specific agenda item. Tom, did you want to add anything to that, or?
Yeah, just one thing, Steve, and this is to the whole board. We would really appreciate it if you'd look carefully at the recommendations in the executive summary. I think we've come to realize that the report is a very technical report and probably will be read by a small audience, but we've tried to write an executive summary and package the recommendations in a way that are readable to a broader audience. So if you could look at it from that perspective and give us any feedback, that would be appreciated.
Okay, thanks, Tom. Well, in your packet today, you'll see a letter from the Delta Protection Commission, comments from members of the State Water Resources Control Board and the California Water Research, as well as a letter from the Delta Counties Coalition to the governor, all stating the value of the Delta Independent Science Board to stakeholders and decision makers, and in support of Senate Bill 821, which reaffirms and strengthens the independence part of the Delta Independent Science Board, as well as stating the need for adequate funding for the board. That bill currently is on the consent calendar of the Senate and presumably to be considered on Monday. And so hopefully by Monday, there'll be a decision made, and then if passed, it would go to the governor for signature. Want to point out, that it's we're really thankful for this overall show of support and recognition of our work. And as an example of that support, I just want to take one quote from the Delta Protection Commission letter as an example. And I quote The commission recognizes the value of a functioning DISB in the role it plays in evaluating the broad range of scientific programs that support adaptive management in the Delta. These nationally prominent scientists have added immense value to the review of Delta scientific research, monitoring, and assessment programs. It is important that they retain an independent status and are compensated to reflect the important role they play in the scientific enterprise. You know, that's very heartening to hear those words. And as I think all the board members, past and present, realize, is that we continually try to make our science reviews, advice, and recommendations, meaningful, impactful, useful, and relevant to the stakeholders and decision makers of the Delta. We encourage and seek input at the beginning of our reviews to try and help us hone into something that's valuable and relevant. And we all know that throughout our various, throughout the process of our reviews, we continually ask ourselves, are we targeting the right audience? What level of specificity do we need from those reviews in order to make sure that they're really relevant? And we have, over the years, improved our processes to get public input at the beginning of the process, like now requiring a publicly reviewed prospectus that outlines our reviews, as well as at the end of our reviews, where we've enhanced our communication products, like developing a 2-page glossy, giving presentations at a variety of venues like the IEP workshop and the Bay Delta Conference to ensure we reach the right audiences. And the recent review of our reviews by the Delta Science Program and the surveys they conducted really confirmed the value of our reviews, but they also suggested we continue to try and seek ways to seek further input from agencies, particularly at the beginning of the review process. And that really is what our meeting today is all about. The entire meeting agenda today, most of it, is designed to ask agencies that do the most science in the Delta about what they see are important issues in the Delta and where input from the Delta Independent Science Board can be most valuable. And this meetings today, what we hear today and what we hear in some other follow-ups to this, will kind of set the stage for our discussion about our next round of reviews as we finish up our 2 remaining reviews on water supply reliability and monitoring. So on behalf of the full board, again, I'd like to thank everyone who has commented in support of our ongoing efforts to secure the independent nature of the Delta Independent Science Board. And we'll move on to our main agenda. Are there any public comments on this item, Edmund?
There are none.
Okay, so we move on to our main agenda, and item number 3 is a summary of where we stand with the monitoring enterprise review. And I believe Tanya's going to take the lead on this.
That is correct. Give us a quick update here. So we had a draft of this report provided to the ISB members in their July packets for our meeting then. And since then, the lead authors have continued to make some revisions on the draft in various sections of the report, also with the support and help of our staff, Edmund, Jenica, and Chelsea. Mostly to the, I would say the synthesis finding sections is where we're putting in most of the revisions right now, but also working on the barriers and challenges section. So we are targeting a draft report for discussion as to whether or not the report is ready for release via the Delta Stewardship Council listserv for public comments at the September meeting. So we're hoping to provide the board members at least a week to review the report before that September meeting. And we're hoping then to get feedback today on whether the recommendations and best practices are targeted and specific enough in the current draft report, or at least the report that was, the version of the report that was sent to members in July. We do have some updates, but again, most of that's not on the recommendations section. So, and just as a reminder too, the recommendations are requiring more kind of transformative changes, and they're directed at really the monitoring enterprise as a whole, while the best practices are targeted more at individual monitoring activities. So with that brief update, I just want to open up the floor to any comments or questions, feedback that any of the board members have on the recommendations and best practices, particularly whether or not they're set to be specific enough or targeted at the right audiences. Anybody have any comments, feedback that they'd like to share?
Yeah, Tanya, I have a comment on the recommendations, and then wanted to say something about the cross-cut budget. With the recommendations, I thought one thing that didn't come out clearly is, it seems to me it's important to distinguish between core monitoring and the other monitoring, because some of that is mandated by legislation. It's very specific.
Mhm.
We really don't have much control over it. We can send a message, but so I thought that was worth refining a bit. And then particularly at the beginning of the manuscript, monitoring for engineering purposes, things like water supply, isn't emphasized enough. I mean, there's a lot of money spent on that, so I would include that. And then my final comment is kind of minor, but there's been a new cross-cut budget. The one in the report is, I think, 2018, 2019. Yeah, there's one for 2019. 2020, and the numbers are actually pretty different. I didn't read it carefully enough to see why they are so different. That's all I have.
Thanks, Tom. Those are great comments. Anybody else want to chime in?
Hi, Tanya, this is Edmund.
Yeah.
I just want to provide a clarification for Tom's question why the cross-cut budget between the 2 years is so different. So for year two, some additional agencies contributed data that did not in year one. So that was the primary driver of some of the changes that we saw in the cross-cut budget.
So we also will give you all time to give written feedback prior to our September meeting, and we'd like to get written feedback actually fairly soon. So by Wednesday, August 25th, we would love to have any written comments. And then we can incorporate both your oral comments from today and any written comments that we receive in the next version, which we will then open up for discussion and hopefully release a week before our September meeting. I believe. Edmund, is that correct on next steps there?
That's correct.
Just a couple clarifying questions, Tanya. So first, the thing that we received in, actually, I think August, July, is not the current set of recommendations. Is that what you just said?
Oh, sorry. I did say we have updated sections of the report, but the recommendations are generally the same. One of the recommendations we're making some edits to, but the version that you received, the recommendations and the best practices are still pretty similar. So you don't have the most up-to-date version, but most of those changes were to the findings section.
Okay, great. And I thought those recommendations looked good. I wondered whether, I mean, you know this as well as I do, people are always looking for economic analyses that can't really be supported because we don't have any monitoring data. So that's relevant for social questions. So I didn't know, is it appropriate to bring that up, or is that I didn't notice much about that.
In terms of the value, articulating better the value of monitoring.
Well, and looking for synergies across agencies. So something I've been able to do in my work is, someone will ask me about one program, what are the benefits of this program? And then I end up going to another program to get their data. And it's not always aligned temporally or spatially as much as I would like, but I do the best I can. So that's just sort of a detail. It's not necessarily requiring a whole new monitoring effort, just coordinating across programs to get at some of the economic and social issues.
Just to add that, Lisa, that there is a section in appendix from the SR report that they had a quite comprehensive analysis of how different agencies participate in the whole monitoring enterprise. So that really is a very good way to go. It has some diagrams, block diagrams, and so on. To the comment of Tom, you are talking about the state mandated ones. They are compliance monitoring, right?
Correct, yeah. I think it's called core monitoring in the crosscut budget.
Yeah.
Yeah, we do have a section, Lisa, on kind of the extent of coordination around monitoring in the findings section that was fairly short in the draft that you received. And I've been working on an expanded version of that section, and that might be a place to kind of integrate the point that you just offered. So either there, perhaps we're also talking in the barriers and challenges section about some of the barriers and challenges to coordination, and but also reflecting on the importance of it and the value of it, to give kind of that mirror of, yes, there are challenges, but there's some benefits if you actually invest in it. So that's one of the things I think we could highlight a little more. Other comments?
I just have one comment, and again, it's just almost a reminder, is that this review is somewhat different than the other reviews we've done, in that it had two components. And the first component was a large contracted effort to do an inventory. And in that, there was a lot of discussion of a lot of the questions that we always talk about. We view our overall review includes that component one and the ESSA reports. Our board members and our team were involved with that process from the very beginning, and consulting and discussing and working through every aspect of that. We are not going to attach it as an appendix necessarily, because it's hundreds of pages long, but it should be pointed out that it is certainly part of our overall report. And what you're reviewing now is kind of we extract some of the relevant information out of that larger report in order to help justify some of our recommendations that we are making overall. But it does include that as it is considered part of our report. So is that it, Tanya?
I think that's it. So we will try to get these last comments integrated. And again, if there are any written comments, please get those to Edmund by August 25th. And we will integrate those and then hopefully have a draft ready before the September meeting.
Okay, thank you. Is there any public comments on this, Edmund?
Yes, we have one from Deirdre Desjardins from California Water Research. Deirdre, I have given you the permission to unmute your microphone. Please state your name and affiliation before providing your oral comments. Thank you.
This is Deirdre Desjardins from California Water Research. And I just wanted to provide some information to the board on the history of the monitoring requirements. So the Water Board's decision 1485 in 1978 set requirements for the Central Valley Project and the State Water Project. And they had specific monitoring requirements for continuous electrical conductivity stations at various locations in the Delta, sampling programs, and so on. And I'll send you a link, but it's been a part of it was also the board reserved jurisdiction when the permits for the Central Valley project and the State Water project were granted, because it was known that they didn't have enough upstream water supply for the permits. In fact, it came out during the hearing for the Central Valley project that both permits assumed the full flow of the Feather River. So the board reserved jurisdiction to set requirements for salinity control and also for protection of fisheries. And that's the regulatory role of the long-term monitoring data set. And that's why I think it's one of the more complete data sets for estuaries. Thank you.
Okay, thank you. Any questions? Okay, moving on to item number 4, which is the our panel. And Edmund, do you have a slide? Okay. This is our effort to begin to set the stage for our discussions about what our new, like I mentioned, what our new reviews might be. So what we thought we would do is, as a first step, is to bring in a number of the agencies as to find out what their thoughts are in terms of what they think are the important issues. And we use the DPIC sort of 1919 to 1920 science expenditures by a funding agency, which is shown here. And what we thought we would do for this first series is we would get the sort of some of the top 3 federal agencies and the top 3 state agencies to give us some initial discussion on the topic. And that's how we determined who was going to be invited today. I should say that the Delta Science program was also on this list, but given the shortened nature of the of our meeting today, Laurel will present that information at our September meeting. And so we are, and we intend to hear from other agencies and so forth as we move along in this process. But this is the first step to get some opportunity of hear some things of what's going on. We've asked this panel 4 questions, I believe. And each of the panelists will have about a 20-minute presentation and followed by a 10 to 15-minute discussion at the, and we're going to take public comments at the end of each of the panelist presentations, if there are any, because some of the panelists need to move on after their presentation. We've asked the panelists 4 questions. The first was to provide us a brief overview of your organization, what science it does in this in the Delta, and how your organization supports or utilizes adaptive management. The second question is, what are your organization's key strategic goals for science? And do they have a written science strategic plan? Thirdly, what are the most important and challenging science issues you see in the coming years? And then fourthly, how can the Delta Independent Science Reviews and Advice assist with your work? So what are you doing? What do you think is important? And are you planning for the future? And how can we help, more or less? I want to say at the outset, I really appreciate, we've tried to pick the top science leads in each of the agencies, and each one of them have agreed to come today. And we really appreciate their time and joining us. We know this is really a difficult time with droughts and everything else going on in the Delta, and we know their time is valuable. So we really do appreciate them coming in. So I want to thank them each personally for doing this on behalf, because this does really help us make sure that all of our efforts over the next few years are valuable and relevant to the community, as well as to each of the agencies that are represented here today. So up first is Mike Chakowski. He's the Bay Delta Science Coordinator for USGS, and he works at the regional leadership level to ensure that that USGS efforts in the Bay Delta are closely aligned with the informational needs of resource managers and policymakers. Before I turn it over to Mike, I did want to say also that our 5 panelists today have a very strong, and each of them have a very strong, rich, and broad history working in the Delta. So they really have the insight of what's going on. And again, we picked people that knew about the science and the science relevancy and the science issues. So Mike, thanks for being here, and take it away.
Yeah, thanks, Steve, and good morning, everybody. I'm happy to be here. I'd like to share my screen, and this may take a second. And it would help if someone could confirm that these slides that I have are actually visible.
We're looking at it.
Let me see if I can switch to there. Is that better?
Yes.
So I am Mike Chakowski, and my title is Science Coordinator for the Southwest region of the U.S. Geological Survey. And in order to answer the board's first question, I'm going to have to do something that I haven't done in a meeting before, which is actually step through from the bureau level for USGS down to the regional level to paint a picture of how we're engaged in the Bay Delta. So looking at the top level, the survey is a bureau of the Department of the Interior, which broadly speaking has the mission to provide reliable, policy neutral scientific information to describe and understand the Earth. And we were created by an act of Congress in 1879. And at present, as of FY21, we receive about $1.3 billion in congressional appropriations and employ about 10,000 scientists, technicians, and support personnel. And we're present in a large number of locations around the country. And furthermore, we're not only divided regionally, we're obviously the violet region on the left-hand side of the map there, but we're also divided into mission areas. There currently are 5 mission areas within the USGS. They are core science systems, which has the primary responsibility to conduct detailed surveys and to develop high quality geospatial data in a variety of forms, covering a lot of different areas of interest. Ecosystems, which is self-explanatory, but I'll add that since the reorganization, ecosystems also includes the social science that USGS does, particularly geography. Energy and minerals, again, largely self-explanatory. Natural hazards, several natural hazards, but natural hazards are in general our mission area, and water resources. So those are the 5 mission areas, and they are subdivided with offices which house scientists who are doing work in those areas across the country. So I'd like to just take a moment to look at our actual mission statement from the survey manual. The first sentence of this is a more precise way of stating what was on the previous slide, the areas of interest of the USGS. But I want to also point out that there's a second sentence in the mission statement which does some work, and that is that the USGS combines and enhances its diverse programs, capabilities, and talents to provide science leadership and contribute to the resolution of complex issues. And we interpret that to mean that one of the things that we are trying to bring to the table as a science provider is the ability to address questions across disciplinary boundaries and to look at particularly difficult problems that frequently implicate a lot of different disciplines. And that the integration of scientific knowledge across disciplinary boundaries is one of our specialties. We do, in fact, have a number of strategic plans. The most recent expression of the Bureau level strategy is contained in this document, U.S. Geological Survey 21st Century Science Strategy for 2020 to 2030. And I've provided a URL to reach the actual document. It's pretty meaty, and it takes a while to digest. But one of the things that it brings out, as stated in the abstract, is that we at USGS in the next 10 years are going to increasingly need to look integratively at the problems that our stakeholders face. And in particular, we're expecting to see more emphasis in these bulleted areas. Integrated multidisciplinary earth and biological science data, geospatial tools, predictive models in various forms, decision support tools, and the expertise to interpret them. In other words, the hands-on interaction between our scientists and managers and stakeholders who have resource management responsibilities. So that's where we're headed. I know we've had a lot of discussion locally about the need to move in some of these directions, but these are actually also national trends. So in our region, so getting down to the portion of USGS that faces the Delta, the Southwest region, which I'm a part, is the 3 states, California, Nevada, and Arizona. And these numbers here, number 8 and 10, the jagged line through the middle there is actually the division between what the department recognizes as Department of the Interior Region 8 and Department of the Interior Region 10. So the Southwest region of USGS actually deals with both of those interior regions. In California, we have 6 science centers at a number of locations, and they have expertise in water, earthquakes, minerals and energy, coastal marine sciences, ecology, and geography, which more or less correspond to the mission areas I described earlier. And all of these science centers are engaged to some degree in Bay Delta science. So we've been here on the Bay Delta landscape for a long time, dating back to probably Jim Klearn's work. I know most of you probably know Jim pretty well, since he's been a member of the ISB. Back in the late 1960s, roughly corresponding coincidentally to the time the State Water Project came online. In the 1980s, we became part of the Interagency Ecological program. We carry out a portion of the compliance monitoring that the IEP does. We also participate in some process-oriented studies within the IEP. In the 1990s, USGS internally created the San Francisco Bay Delta Priority Ecosystem Science Program, which I'm going to talk about briefly a little bit later, which is our internal program, which has very few strings attached to it in terms of its area of focus. And we use that program to address issues that we think are science issues we think are really important ones to be addressed in this system. And we have labs and science centers that are working on Bay Delta issues in the Bay Area, in Sacramento and Santa Cruz, and we have some subsidiary locations elsewhere. So our Bay Delta portfolio, the work that we're doing that's relevant to the Independent Science Board's brief, in federal fiscal 21 included more than 170 individual projects, totaling about $32 million in program. As reported in the crosscut budget, this is a typo, it's really about 6.7 million of that is, those are appropriations to USGS, predominantly in the ecosystems, water and core sciences, ecosystems, water, core sciences, and natural hazards mission areas, with ecosystems being the largest portion of that. And we also do about $25 million worth of work that's supported by reimbursable contracts with our partners. There actually are 7 science centers involved in our Bay Delta activities. I've previously mentioned that we have centers in California that are working here, but we also have a center, the Western Fisheries Research Center, which is focused on fisheries issues and is headquartered in Washington State, that does work on anadromous fishes in California. And the last thing I'll mention is that we have an internal program council, which we use to have multi-mission area discussions of Bay Delta issues, particularly as they pertain to our priority ecosystem science program, which is a portion of our appropriated budget. So we're covering a lot of ground at USGS, and you can probably tell that just from the size of our overall Bay Delta programs. A lot of the things that we're doing are not really visible to the Delta, especially the water management community, and are not things that we talk about a lot in the Delta science community. But a non-exclusive short list of the biggest areas where we're working include the items on this list: water quality and availability. That would be surface water operations related monitoring and science and research. Sediment transport, contaminants, ecology and trust species biology, science that's related to habitat restoration and habitat alteration that can take place for a variety of reasons, including climate accommodation, flood and seismic hazard, land subsidence, particularly the kind that's associated with, we particularly are working on the kind of land of subsidence that's associated with aquifer depletion, groundwater depletion. But we also have some studies that are underway in the Delta where there's subsidence due to peat oxidation. And we have some lines of research that are related to carbon sequestration that are associated with that. And the last thing I'll mention is that we have a substantial internal program in climate and climate impacts. Not just the impacts part of it, but climate research itself. So we have scientists who are working on predictions of regionally downscaled hydrology from climate models and who are interested in predicting the course of the evolution of climate. So it's a pretty broad spectrum of activities, and I don't really have the time here to get into it in depth, but I just want to mention a few high points that'll be familiar to the Delta community. One is the work that we do that's related to surface water dynamics and water quality. We have a large gauging network in California, and we also have a constellation of stations that I mentioned before in the Delta that we use to monitor hydrodynamics and water quality to support real-time operation of the water projects. And a lot of the work that we're doing within the Delta is very tightly tied.
You want to put it in a way that you could see it?
Beg your pardon? Oh, it sounds like somebody just slipped off of mute for a second there. So a lot of that work is very tightly tied to the water project operators, and it's part of the IEP program. A second area is sediment transport. Sediment is in our view, and for a long time has been our view, is the key physical science element that is going to affect the outcome of efforts to manage, and restore the Delta, and more recently to armor the state against sea level rise. And we have worked in sediment in a number of respects. We do monitoring of sediment dynamics, and we also do a lot of process-oriented study of sediment. Another is contaminants. We particularly look at some of the legacy contaminants like mercury, and also more recently we've moved into agricultural pesticides and pharmaceuticals that have become something that people are much more aware of, and possibly have become a bigger problem in recent decades. So we're conducting studies on those in order to support management decision making. We also do a lot of trust species research. In the Delta, people predominantly focus on fishes, but we do work with not only with Delta resident and anadromous fishes, but we also work on terrestrial animals, birds and plants. across throughout the watershed, actually. And we do a lot of work that's informing habitat restoration, as I mentioned before, understanding sediment, understanding contaminants, and understanding really the dynamics of the biological elements of restored wetlands. And we do natural hazards work. They're particularly here, we do work on seismic hazard. A lot of the work that our Earthquake Science Center does is not specifically Bay Delta related, and we don't report it as part of our Bay Delta portfolio, but we do have a few elements of the Bay Delta portfolio that are carried out by the Earthquake Science Center. And they are actually funded by our internal priority ecosystem science program, and they are looking at refining our understanding of the seismic hazard in the Central Valley. But we also, in our Coastal and Marine Science Center in Santa Cruz, we are also doing work to model the impacts of flood events and sea level rise in the estuary. And I mentioned land subsidence, so I won't dwell on this, but climate impacts, we've been very interested nationally in long-term changes in hydrology, and we did some of the seminal work on atmospheric rivers in California, which are part of the equation in terms of understanding long-term changes in hydrology. And we've developed models at various scales to better understand the regional and local effects of predicted changes in climate going over time. And with that, I'll just transition into a few comments about how we set priorities internally. And then I'd like to just talk about the Priority Ecosystem Science Program, which is a piece of our Bay Delta program briefly. So overall, I think we want to emphasize that we support the Delta Science Plan. We have thought that it's well motivated and it's a good tool for the job that it's being used for. We do use the Science Action Agenda as one of the inputs in our internal planning processes, and we also we do have a number of our scientists that we encourage to participate in the development of priorities that occurs under the heading of the Science Action Agenda. And we also contribute significantly to the State of the Bay Delta Science publications that are produced. We have scientists who are co-authors on a lot of the chapters and lead some of the chapters. I would say at this point that because of the broad scope of work that USGS does that's Bay Delta related, it's difficult to give a ranked list of where we think the priorities are, the biggest challenges. I'm saying priorities here because I'm interpreting the board's question regarding biggest challenges as really pointing toward priorities. But they certainly include, over the foreseeable future, better understanding of surface and groundwater. We're really working on both of those, even though the groundwater part isn't really visible in the Bay Delta management community. We're working on trust species biology. As I mentioned before, it's a high priority because the changes, the trajectory of changes that we've seen in the Bay Delta has made it pretty clear that these are going to be matters of major management interest for the foreseeable future. And we have the expertise to contribute in a number of different areas and are endeavoring to do so. We're spending a lot of time studying what I've described here as the physics of shoreline evolution, really the role of sediment, and the future role of sediment, and the things that modify sediment dynamics as potential determinants of the outcome of restoration and climate adaptation efforts. And by modifiers, I'm including a lot of things that are biological, ranging from biofilms to aquatic macrophytes, all of which have the potential to modify the way sediment gets distributed. And of course, climate science, because of the threat that a lot of our stakeholders perceive arising from sea level rise and from changes in hydrology. Those are areas of great interest to us where we're trying to contribute our expertise and both with appropriated dollars and on reimbursable funding to provide information. And lastly, natural hazards. And I think we often overlook the potential importance of the seismic hazard. And we're continuing to keep our eye on that until we have a better understanding of the nature of the seismic hazard in the Central Valley because of its potential effects on water infrastructure, levees, et cetera, that are pretty important to the management of the Delta. So I mentioned that we have this internal program called Priority Ecosystem Science. It's funded by the Ecosystems Mission Area within USGS. And it does not come with a specific mandate from the Bureau level that limits how we can program these funds. And so we have the freedom to look at the science enterprise that we see here and pick the places where we think our expertise can make the most difference in terms of informing decisions. And we have about a little less than $2 million a year in this program annually. So it's a little less than a third of our appropriated support, and it's less than 10% of our overall program. But it's an important, and I manage it, so of course I think it's important. But I think we generally agree that it's a very important element of the work that we're doing here. And we use an internal program committee that we constitute when needed to set priorities for this program, to set areas of focus. And the current ones are described here. And just to summarize them, the synthesis and integration priority is really intended to encourage our scientists to look at broad bodies of data that are available for the Delta, particularly historical data, and to align them against one another and try to learn new things about how the system operates and draw more knowledge out of the historical data than has been done before. And I think we've had some real successes in that area. Most recently, we did a synthesis of sediment dynamics in the Delta that actually covers other fields, and it's something that I think we believe, and a lot of others believe, has been underemphasized historically. The second one, the multi-stressor problem, is one that it's a vector that points in a somewhat different direction from the synthesis and integration priority, but it's not orthogonal to it. It's like 60 degrees. But it looks at the question of synthesis from the point of view of the challenges faced by managers, where they may have to deal with multiple stressors, and each of which has some management hooks associated with it, some knobs that they can turn. And our aim in this is to try to help them make better complicated decisions. And last, natural hazards is a priority for the reasons I stated earlier, that we need to understand the seismic hazard in the estuary, the Delta particularly, better. So the big question that the ISB asked is, what are we doing to support or implement adaptive management? Well, we don't implement adaptive management because we don't manage resources or infrastructure. But given that the received definition of adaptive management these days, especially by the managers, is science that supports management, I would say that essentially everything that we're doing supports adaptive management. A lot of it's we do a lot of work particularly that supports surface water management and planning for surface water management and for restoration and climate adaptation, as well as some of the other things that are not really in the purview of the Delta community, but occur in the estuary that I mentioned before. I think from our perspective, the body of reviews that the ISB has done have been extremely helpful. Most of them have been very on point in terms of addressing the questions that should be addressed. And so I don't offer any criticism or any suggestions that things be done differently. I just would like to point out, especially going forward, a couple of things that the ISB might want to consider when they're doing program reviews. And I'm brought to these suggestions because of some dialogue we've been having over the last couple of years about science governance and about whether the science enterprise, which is to say the collection of all the science programs and science actors that are active in the Delta, are doing an adequate job of covering the bases. So my first comment really is intended to provide a different frame of analysis for looking at science activities that I don't think has been used all that frequently in the past, but I think is really helpful. And that is that frame of analysis is to recognize that a science enterprise has to really do three things. I mean, you're doing science in order to do these three things, but you're trying to accomplish three things. The first is to react to known management needs and to management information requirements that have been set forth by the managers. The second is to anticipate future needs, things that haven't been thought of yet, at least haven't been clearly formulated yet, and needs for managers that the managers themselves have not already articulated or don't recognize presently. And the third is to just address surprises. Sometimes things come up that provide an opportunity to learn something. For example, we just saw some evidence the past couple of weeks that there's something of a bloom of cyanobacteria that's going on in the South Delta right now. And so the question was asked, is this related to the drought barrier? And I don't know the answer to that. We're looking at it right now, and I'm raising that not because I think it's an issue, but because I think it's the kind of thing that represents a surprise that a science enterprise should be able to respond to, should be able to put people in the field, put capabilities in the field to address questions that pop up out of thin air. And what I suggest to the ISB is that when conducting a program review, it'd be worth asking the question whether the individual programs are apportioning their resources in the most efficient way they can, particularly between reacting and anticipating. And our program, the USGS program, we do both of those things. A lot of the work we do on reimbursable dollars, for example, hydrodynamic monitoring, is reactive. We're reacting to a stated need of the water projects. But we also have some areas of our program that are really focused mostly on anticipation, including priority ecosystem science. We're really focused on looking farther into the future in that program and not reacting so much to immediate management needs. We're trying to imagine what will be needed 5, 10, 20 years from now. So that's something that I would suggest the ISB consider, this particular frame of the functions of the science enterprise when looking at individual programs. Not all of them have to do all of the same thing, but we need to have a functional whole, and programs have different ways to contribute to that. So the context of the program is important in the review. And the second observation is that I think that ISB ought to be thinking about data stewardship and delivery going forward. This didn't used to be a problem, but we've already seen, in the last few decades, that in certain areas, for example, in surface water operations, the monitoring that's necessary, the data that are required to do those, to conduct those management activities, add up pretty quickly, and they also become hard to serve. So that we've seen things like CDEC that have been created to provide a one-stop place to obtain data related to water operations, and some others. But I think it's pretty clear, especially as we come to rely more and more on remote sensing and we develop more complex environmental models that things are going to get out of hand, and that we're going to need a better global strategy for data stewardship. So almost none of the individual programs, there are exceptions, the IEP is one of them, but almost none of the smaller programs has data stewardship as a high priority or a major budget item. And I know somebody out there is going to yell about this, so apologies in advance. I know there are exceptions, but it's something that we need to do more of. And I'll just give an example of why. The California Water Science Center, which is the USGS unit that does water in California, has a split in the organization with a substantial fraction of the staff doing studies and a substantial other fraction of the staff doing data stewardship. And I think that model that they have is one that indicates the direction that I think we're going as a community in the future. We're going to have a lot more emphasis on data stewardship, and I think it would be helpful for the ISB to think about that when they're doing program reviews. Maybe make advice along the lines of preparing for that future. Otherwise, that's all I have to say. And thanks for the time, and I appreciate the invitation. I'm happy to be here and also happy to answer questions.
Thanks a lot, Mike. Any of the board members have any questions?
I'll ask one if no one else has one. So Mike, this might be a hard question. What percentage of the research that you do would you say feeds directly to some sort of decision process versus being more the groundwork?
Mm-hmm. It's hard to give a precise answer. I would say a large fraction of the work that we do on reimbursable dollars in the Delta goes directly to supporting decisions. Some of the work that we do in areas that are not the areas that are really visible in the Delta probably don't contribute immediately to adaptive management decisions in the Delta. So I think there are some areas where it is hard to answer, sorry. But I think it's quite a lot overall.
I've got two questions for you, Mike. One is a simple one. On your reimbursable, who gives you the most money? Where does that money come from?
Our biggest reimbursable partner is the Bureau of Reclamation, followed by the Department of Water Resources.
Okay. The second question relates to trying to get your ideas about what sort of reviews might be valuable in general for the Delta. I know you've been involved with the DPIC, on a DPIC panel looking at sort of future science needs in the Delta and all of that effort, as well as the original Science Enterprise Workshop. If you had to be pinned down, is there a topic or two that you thought just is screaming out for a review by the board?
Well, you're kind of putting me on the spot.
We won't hold you to it, and it's not really being recorded, although it is, but
yeah,
we're brainstorming now.
I don't know everything you're doing, so I'm taking some risk here of suggesting something that may already be in the works, but I think our use of large-scale modeling effort, large effort modeling to do forecasting for water operations or for estuarine conditions or for sediment distribution over the long run. Those are things we should be doing, I think, and it would be helpful given that there are a lot of people in the Bay who are doing one set of things and some people in the Delta doing other things. That a review of what's going on estuary-wide might be pretty helpful in terms of helping us focus.
Okay, I see Tanya had her hand up.
Yeah, just a quick question. Thank you, Mike, for the presentation. It was great. And I liked how you set up the three functions of the science enterprise. And I'm just curious to kind of hear your thoughts on across those three areas, the react, anticipate, and address emergencies. Do you think the Delta science enterprise as a whole, so not just the work that USGS is doing, but as a whole, where are there the biggest gaps in those three functions?
I think we do a great job of covering React. So I think there are some refinements that we could make in the area of addressing needs that we already know about. But I think we're doing a pretty good job overall. I think we're coming up short in the other two areas. And I don't think it's a huge challenge to prepare for emergencies. So that requires a strategic plan for addressing emergencies. What sorts of things might come up, HABs outbreaks or a broken levee. I'm just throwing those out right now, but I think we can draw up an inventory of emergencies or surprises that we might see in the future, and we can draft a plan for that. And I don't think it would be all that expensive to implement it. We just need to do a bit of homework to be prepared. The anticipate is the hard part, and it's hard for a couple of reasons. One is because it's hard to anticipate, what's going to happen. So just be plain about that. But it's also hard to get funding for anticipatory science because it frequently appears to fall outside the institutional interests of the funders. So I think advice from the ISB in the need to do that, and maybe directions where that should be taken in doing a better job of anticipating, and including not only advice as to what to do, but also in what program context or via what governance method we might get to that endpoint. That kind of advice would be helpful.
Any other questions from the board? Okay, Edmund, any questions from the public?
There are none.
Okay, well, thanks a lot, Mike. Very informative, and I'm sure we'll be getting back to you and asking for more advice.
You're welcome. Good day, all.
Okay. Our next panelist is Rachel Johnson, and Rachel is a research fisheries biologist and project leader with the NOAA Fisheries Southwest Fisheries Science Center, and also an associate researcher with the University of California, Davis Center for Watershed Science. She works with scientists, stakeholders, and decision makers to reduce key scientific uncertainties around complex water and fisheries resource management issues in the California Central Valley. So Rachel, thank you for being here, and we're looking forward to hear what you have to say.
Thank you so much. Thanks for the invitation. And Steve Lindley, who's the director of the Fisheries Ecology Division, sends his regards. He's looking forward to meeting the newest of the ISB members, hopefully face-to-face someday soon. In his stead, I am going to be sharing an overview of what we're up to at the Southwest Fisheries Science Center as an organization, and specifically the role I play in the agency is one of a translational ecologist. So I'm a science liaison between the work that's being done at the Science Center in Santa Cruz and decision makers in Sacramento. So I'm strategically located at UC Davis, where I have a large research program there in my own right that I will showcase in a little bit, as well as making sure that the decision makers that are making important decisions primarily for our regional office for NIMS have the most up-to-date science that they need to be making the decisions that are the most challenging decisions to make for California salmon and water. And so the Southwest Fisheries Science Center had a very focused early beginning in the 60s, where we were charged with focusing on understanding the impacts of the sardine fishery and a focus on tuna. And today's mission is much broader. The Southwest Fisheries Science Center is responsible for generating important science necessary to support kind of harvest management, as well as more kind of ESA type obligations now for a whole variety of species, not just kind of the pelagic sardine and kind of the larger migratory species in the ocean. And so we do have this kind of harvest management obligation under the Magnuson-Stevenson Act. We have these obligations around, and opportunities, I should say. Obligations seem so loaded. Opportunities to help with conserving and recovering species. And we take an ecosystem approach in kind of both of those kind of mission areas that we work in. I wanted to take the opportunity nationally. NOAA has an emphasis on a Species in the Spotlight program that's about 5 years new. And it is an effort to try to get our partners to help move the needle on the most endangered species that are kind of managed by NIMS. And I highlight this largely because of the 9 species that are most threatened that NIMS is responsible for managing. 3 of them are endemic to California. And so I'm highlighting our white abalone friend, Central California coho, as well as Sacramento winter run Chinook salmon. And for the purpose of kind of the focus of the research that I'm going to share with you today, the winter run Chinook salmon is kind of the most relevant for the kind of the Delta conversation. I mentioned again, we have kind of these 2 authorities, the Magnuson-Stevenson Act in terms of providing stock assessment for better sustainably managing our ocean fisheries, our tribal fisheries, as well as commercial and recreational, as well as our Endangered Species Act in terms of being able to support providing science to support recovery for these species. We are located, the Southwest Fisheries Science Center covers California and the Antarctic. And the mothership for our agency is down in La Jolla near San Diego, where Kristen Cook is the center director. And again, the research teams there focus on large migratory species, on marine mammals, on turtles, on stock assessment. There's an Antarctic division. So the breadth of work and responsibility is pretty vast. We have the science centers that are more strategically located to our Central Valley work. That's primarily our office, the Fisheries Ecology Division located in Santa Cruz. And we have a strong academic partnership with UC Santa Cruz, and NOAA in particular has efforts to strengthen our academic partnerships through our fisheries collaborative programs. My research lab is at UC Davis. I also have a linkage towards our agency mission for enhancing and strengthening our academic partners, mentoring graduate students, working with other faculty to use the tools in the academic toolbox to bring a lot of scientific integrity and credibility to kind of interdisciplinary work that we're focusing on. We approach both of our work in the ocean as well as in the Delta with an ecosystem-based approach, with kind of predictive models being central to all of them. From an adaptive management perspective, we really focus on building models that allow us to predict how changes in climate and human activities will influence our species that we manage. And we translate this to make this information available to our decision makers and managers. Again, just to paint kind of the broader scope of the work that is done at the Southwest Fisheries Science Center, these are the kind of examples of kind of the key species and areas of expertise and focus, and our management authorities for needing to kind of support science for important decisions that are mandated by our agency. Particular emphasis for this conversation on the California anadromous species. I borrowed this figure from Carol Inquist that I like so well. It's a way of thinking about how organizations are structured as it relates to science and science generation and science use. And NOAA Fisheries is a boundary spanning organization, which I like so well. The science centers are really here on the left side of this diagram. We're real knowledge producers, so conducting research. And colleges fit in this category. Science agencies, I would say USGS falls into this research category on this spectrum. And so the NIMS Science Centers play this fundamental role. On the other side of that continuous boundary spanning role is the use of science, so knowledge users. And our regional offices are the practitioners of our organization. So a lot of using science to make those tough decisions on the listing status of species, for example, or what kind of temperature compliance needs there are for water project management. So that's the practitioner side of the house. And what I think some people don't appreciate about the common name of NOAA Fisheries is that we really do have these distinct lanes that the science centers and the regional offices play. they're as different from each other from a governance and from a kind of leadership hierarchy as USGS is to Bureau of Reclamation, where USGS is the Science Center for Department of Interior. NIMS Science Center is the research arm for Department of Commerce for NIMS. So where USGS and Reclamation are separate until they come together in DC, they come together at one higher level, then the NIMS Science Center and the regional office come together first in DC at our Assistant Fisheries Administrator position. So while we do have our very distinct lanes and responsibilities, we spend the bulk of our time at this interface. And that's what's so cool about being a part of a boundary spanning organization, where the work that we do is very aligned between the science that needs to be done to support the decisions that our agency is making. So we spend a lot of time at this interface, and this is reflected in our strategic plan. So I think I've sent to you all our West Coast strategic plan. And I just want to highlight that the director for the Southwest Fisheries Science Center, Kristen Cook, and Kevin Werner from the Northwest Fisheries Science Center, along with the West Coast Regional Administrator, were responsible for putting together this guidepost, which shows the intersection between doing very management relevant science to support those key decisions. So what does that look like as it relates to our role in the Delta? So the primary players on this in the Delta are the Southwest Fisheries Science Center, but specifically the Fisheries Ecology Division that is housed in Santa Cruz. And that would be the Central Valley Area Office for the West Coast region. And so our partnership is very important in the work that we do in the Delta. And the work that I do is really this translational ecology piece. And we annually align the work that the Science Center is doing in support of the key decisions and the management challenges that the regional office has. To Mike Chakowski's point, the primary role that I play is trying to follow the puck and trying to read the tea leaves in terms of trying to figure out what the next burning questions are in the management side of the house and align resources so that the science can get started and done by the time the decisions need to be made. For those of you who do applied science, this is no surprise that that is one of the biggest challenges, is being able to actually do the science, which sometimes can take a decade, so that when the decisions are being made, you have the science to make that decision. It's often the other way around, right? Like, oh my gosh, there's a drought. We need information on what temperature the salmon need. And it's like, okay, well, we don't have that today, but for the next drought, we will be prepared. So trying to anticipate what those look like is kind of one of the key functions that we play in the Delta for our Central Valley office. Again, one of the ways that we plug in is through the science collaboratives. So we fundamentally believe that the way to move the needle in our politically charged Delta is to try our hand at some of these collaborative science approaches that have worked in other systems to be able to do joint learning, do co-production of science so that we can move away from combat science to the extent to which we can. And I will come back to this because I think that there's a role for the ISB to play in our piloting and navigating these important collaboratives. So I'm sharing with you, I also shared a handout of kind of the organizational chart for the Fisheries Ecology Division. And in these blue boxes, I've highlighted different research teams that conduct research relevant to what's happening in the Delta. And so I'm gonna do what I do, which is I'm gonna take this opportunity to not only amplify and showcase the work that's being done in the Delta, but I'm also gonna use it as an opportunity, since so many of you are from out of system, to give you a little bit of a primer of what we've learned from these different teams about salmon in the system. And so I will just kind of showcase that with that intent in mind. I think we spent a lot of time about talking about what we don't know in the Delta. And I want to share with you that we know a lot about salmon in California and their need for the Delta. And so I'm going to take those lenses to kind of share with you some of those salient synthesis pieces as I talked about the different work that the teams do. So the first thing I want to share with you is that we have a heavy hand in adaptive management. And I would say that developing these two predictive tools in particular, and these decision support tools specifically, are some of our strongest ways that we directly assist in adaptive management, or the science support for adaptive management, I should say. So again, we spend a lot of our time building models that allow us to predict how changes in climate and human activities influence the species that we manage. We translate that very actively to managers. So we don't just publish things in the scientific journal and hope that our managers find it, right? We actually spend a lot of time talking about what we're doing and our findings so that the most relevant information is at the decision tables. Our guiding principle is that we focus on areas where our expertise interfaces with problems we think we can solve. We're a pretty small group, so we need to be pretty scrappy with our resources. And we have a lot of expertise, and there's a lot of problems out there, but we really try to align our focus on areas where expertise allows us to solve some of these problems, which means that we don't do a lot of monitoring. We rely on a lot of our partners for that. We choose to focus on synthesis, the development of quantitative and predictive tools, and special studies. So what I'm showing you here is kind of a slide that's to showcase the life cycle model and our temperature modeling. And I want to share that the ISB had a heavy hand in this already. After the 2009 biological opinion was remanded by the courts, the judge said, NIMS, you better show up with the life cycle model the next time that a biological opinion shows up in court. And so the ISB played a heavy hand in convening with under the stewardship of the Delta Science Program, a workshop to evaluate the existing winter run life cycle models, which there were probably like 23 of them already in existence. So maybe there's one off the shelf we should be using. But the ISB's recommendations and conclusions were incredibly helpful and informative. And the ISB concluded that we needed our own to be able to assess the impacts of the actions of the water projects. And so that's what we've done. And we also have our own kind of ISB in NOAA, which is the Center for Independent Experts. And they've also reviewed kind of more of the intermediate products of the life cycle model that we're using today in adaptive management. We have active stakeholder engagement in this. And what we've learned is that we really do need these models to understand these carryover effect. They're nonlinear, they're complicated. You tweak one thing in one life stage and it has unintuitive consequences to the population dynamics. Some of the things that we've learned, what I'm showing you here is a graphic of our temperature model, which you can see the red is like hot and the blue is cold. And these are gradients from Keswick Dam in the upper portion of the anadromous barrier for winter run and where they spawn in the upper portion downstream. And you can see that this is the top one is kind of the 25-year average, and below it is what happened in the drought. So when Shasta ran out of cold water. So we use these tools to try to understand how water operations and temperature management is going to influence this endangered fish, and in particular, quantify the impacts of egg mortality. We've learned through the work of the temperature dependent modeling and mortality in the life cycle model that if you want to do restoration, the success of that restoration is going to be very context specific. It's going to really depend on how many adults are there to spawn and the flows and survival that those juveniles have. And at current winter run densities, a bunch of habitat restoration for the Delta is not going to be very meaningful for them, not at their current densities. So we've learned a lot in terms of how to move the needle on actions to help winter run specifically. We were conducting these survival studies with multi-agency partnerships. You'll probably hear more from Josh Israel, Reclamation, and many of our partners have helped to stand up this real-time acoustic telemetry array. Mike Tchaikovsky spoke a little bit about that. It's really cool. You tag these fish and there are these receivers across this constellation of receivers. You can track the survival of fish. There's an underlying Bayesian survival routing model that underpins it, so you can actually see survival probabilities. And you can on your iPhone check to see how well they're doing. So my kids and I actually, because we're a nerdy fish family, had a betting pool around 2 release groups of fish that I thought one was going to have higher survival. It turns out that I was wrong. But you can on your phone track the status and the movement of these fish. We've learned that the survival of salmon in the Delta is pretty poor, but it's pretty consistently poor. And what we were surprised to learn is that there's even lower survival in the upper portions of the watershed and in the river. And yet you can have a 5-fold improvement of survival with flows. We've learned that winter run Chinook salmon, even the hatchery ones, can spend up to 45 days in the Middle River in the Sacramento. We've learned that, that salmon survival depends a lot on their travel time in the Delta and which complicated routes they take to go to the ocean through the Delta. We've used this technology with coded wire tag releases to do trawl efficiency estimates. And so now we have real abundance estimates annually for winter run leaving the Delta, which is having huge impacts for our ability to develop these predictive models, to be able to decouple freshwater from marine survival, and really allows us to see what the cohort strength in a given year is. Because survival can be pretty poor in the Delta, we have a research team looking at the role of predation. And what we've learned, there are these predator event recorders that are super cool. They're these like floating buoys that are slick. They have a dangling salmon at the bottom of them. And once a predator takes them after they float down the stretch of the river that you're looking for, it records the time of predation, the location, and it takes a picture with a GoPro of the vicious predator that took the salmon off the hook. And what we've learned is that predation is patchy and it's exceedingly high in particular locations. So here's a heat map that I've shown you up there. But what we've really learned is that water temperature is the main story of predation for salmon in the Delta. Once the Delta gets above 20 degrees C, Delta survival for salmon is near zero. And it's because at those temperatures, the performance ability of salmon goes down and the metabolic capacity and demand for largemouth bass goes up. And so this allows us to then estimate from a phenology of temperature in a given year, what is the outmigration window that we can expect for salmon? And we can then predict that with future climate change. We know that these man-made structures have increased risk of predation in the Delta, especially with artificial light. So what about life history diversity? So work that my team is doing is looking at archival tissues, primarily the fish otoliths and their eye lenses, to be able to reconstruct habitat use and their growth. And we've learned that the diversity of outmigration strategies is the salmon's way of bet hedging and spreading risk over space and time. Some groundbreaking work that's just coming out by Flora Corleone in the journal Nature Climate Change, it's due out, shows that during droughts, the only outmigration strategy that works for spring run salmon are leaving as yearling fish. The fish that leave, the majority of fish, and they leave at this kind of intermediate size on the size spectrum that I show you here, they don't make it out of the Delta in the drought. It's only these yearlings that stay in the river and they're on Mill and Deer Creek in this high cold elevation habitat and leave in the fall that come back and survive to tell the tale. So this rare strategy ends up being a really important drought resilient strategy. We've learned that we shouldn't write off the smallest among them. So this little fry at the bottom of this spectrum, it turns out in wet years, they can come into the Delta, they find good rearing habitat, they grow well, they survive, and they go back to spawn and tell that tale. So the Delta is not an all bad black box, that these salmon have evolved to use it as rearing habitat, and a certain proportion of them successfully do exactly that. And we know that reservoir operations really influences the size and timing that juveniles decide to kind of use these different mosaics of habitat. Our molecular ecology team has been doing some high impact science, publishing in Science and Nature, it feels like every other week. They've been able to find the genetic association that determines run timing in the variety of salmon that are genetically distinct in our system, as well as the genetic components that are the architecture for anadromy for steelhead versus those that choose to stay in the river. We've been able to use parentage-based tagging to be able to show that our two reintroduction efforts of winter run on Battle Creek and that in the San Joaquin reintroduction area have been wildly successful, that those fish left as juveniles, they survived, and they came back to spawn, which is the first part of actually reestablishing kind of self-resilient, self-sustaining populations. We've learned a lot about kind of the ancestral genetics of steelhead above barriers. We also are very proud that we have always had social scientists on our team. Fisheries economics is a really big part of what we do, and we've been able to point some of our social scientists into some of our inland challenges. So Cameron Spear has been able to look at the costs of reintroduction. So one of the key strategies for nymphs for salmon on the landscape is to reintroduce them, especially when you look at how limited cold water is going to be in our climate future. back into their historical habitat where they have access to that cold water. But that's super costly. When you actually tell people how much it's going to cost to put fish above a barrier, it's like a non-starter to when you see those numbers. But it turns out it's not a non-starter. So Cameron Spear did some analyses looking at the utility rates that consumers would have to pay a little bit more to be able to fund the needed infrastructure to conduct some of those reintroductions, particularly on the Tuolumne. We've also been able to use our own in-house socioeconomic evaluations to combat some of the charges in the courtrooms around curtailment of environmental flows and impacts to farm labor. And while export curtailments do have different impacts to agriculture in terms of shifting crops and a whole variety of groundwater draws, it has not influenced the labor market to the extent to which people had thought.
Rachel, you have about a minute left.
Gotcha. I will be wrapping up. Our landscape ecology team is using novel technologies to be able to do remote sensing and helping our regional office make choices around where reintroduction is going to be the most effective. To Mike Chakowski's point, we actually internally, working with the Delta Science program, were able to stand up a whole line of inquiry around thiamine deficiency, which is a new stressor that started in 2020. And we have assembled a team to be able to learn from how we could potentially understand this big reproductive failure that's happening in our system. And we've made big headways, largely due to the Delta Science program being able to have emerging science needs funding. So to that point, happy to talk about that and our findings further in our discussions. The question was posed, what are the biggest challenges that we see for our agency as it relates to the work that the ISB is focused on? I would say the need for, we think climate change is going to be the biggest thing confronting salmon in the climate future, as well as being able to eke out a living on the landscape. This is work that Lisa Crozier has led that I was a part of that shows that the Central Valley stocks are the most vulnerable to climate change. So I think our science enterprise, while I know the ISB focuses on the legal delta, our science needs to transcend all of that to be able to take a holistic approach and an interdisciplinary approach to be able to recover these animals. And then my last slide is just to say, I'm a consumer of the ISB reports. The Fish and Flows report in particular has been very impactful for the work that we do. I try to farm that out and amplify the recommendations in that everywhere I can. I think that the brain trust that you guys have in your group is incredibly powerful. Sometimes I daydream about pointing you guys onto different pet projects and challenges that I think I could use your brains on. But in thinking about the question that was posed to Mike about where some potential science reviews could lend themselves, I would say that the ISB's good brain in evaluating our collaborative science programs would be really well welcomed. I think that you all may have some experience in your own watersheds and other systems on integrated watershed sciences, on how, from a governance perspective, to accomplish collaborative science, as well as maintaining scientific integrity in the work that gets undertaken in those processes. We have the luxury of having some older collaboratives, the camped one being the longest standing one. It would be helpful to do a review of that to actually get lessons learned, the extent to which you guys want to embark on some social science components of it, to ask individual stakeholders and agencies whether or not they think the collaborative is working to achieve the goals that it was set out to do, and an evaluation of the science that's coming out of that, and whether or not we are actually achieving the goals of staying out of the courts by potentially doing co-production with science. And we've got other more nascent efforts that are building off of that model. It would be helpful to know if that is the right model, if there should be other models we should be pursuing. So I guess I will end just by leaving that as an open potential assignment that you guys could consider. And just to also say that we have a lot of expertise at the Science Center. Consider us a resource. As you guys learn more things about the system and the work that's being done, please don't hesitate to reach out to Steve Lindley directly or myself if there's any role that we can play in helping you guys in the work that you do. And I appreciate your service. So thank you so much.
Well, thank you, Rachel, for coming here today and for your talk. And I would love to talk a lot about salmon and whether or not you think salmon are still going to be around in a few years. But I won't ask that. I'll ask a more general question, sort of amplifying on your sort of comment that you made about your thinking about the sort of the next burning questions, and maybe not necessarily exclusively within NOAA or NIMS, but on a broader scale, because I know you keep your fingers on the pulse of everything that's going on in the Delta. If you were to pick a topic or two that you think would be really relevant for us to review, a science topic, I know you're talking about the governance aspect, but what about science? Is there a particular field, or you mentioned fish and flows before as something that was very useful, but is there another thing like that you think might be a valuable approach?
Well, I think in terms of kind of science evaluation, I think that the collaborative science program also has that social science element around the governance, but I also think that there's touch points there around the work that's being recommended that could possibly use some strong recommendations around how you successfully have rules of engagement around what that looks like. And those collaborative science programs and partnerships are identifying a lot of science priorities. So I think just being engaged in what those groups are identifying as science priorities and helping make recommendations on how to launch them successfully, so that at the end of them, there is buy-in on what the results are, right? Because that's the value of doing collaborative science, is that you hope at the end of it that you've tested all of the disparate hypotheses and you've done that with such integrity, and that people see themselves reflected in whatever that scientific effort is, that at the end of it, people agree, yep, that's what we all agree that the science is saying, rather than kind of these fragmented studies that we then kind of say, well, this study said this study said that. So any recommendations you guys have about how to set up successful interdisciplinary, multi-stakeholder scientific efforts on the priorities that those groups are setting? I have my own sense of science priorities. For example, as part of the salmon recovery workshops that camp is doing, NIMS's recovery plan would indicate that we cannot recover salmon on the current landscape without reintroducing them into their historical habitat, flat out. That water is getting warm. These are cold water fish. If this year is any indication of what the future climate extremes look like, which I think it probably is, we need better recommendations around kind of amplifying independently the extent to which salmon, I mean, this goes into your first question, whether or not we can recover salmon. Are they going to be here in 10 years if we don't do anything differently? And I think trying to marshal what kind of science we need to be doing to be able to think about providing kind of climate resiliency to our salmon populations, I think that the reintroduction conversations would be valuable to kind of evaluate the extent to which it needs to happen, because there's some haters out there that don't think it needs to happen. And it would just be helpful to kind of get kind of other thoughts around that, and maybe other disciplines thinking through what recovery could potentially look like.
Thanks. Board member questions? Okay, well, thanks again, Rachel. Edmund, any comments or questions from the public?
Yes, we have a public question from Deirdre Desjardins. Deirdre, you have permission to unmute. Please state your name and affiliation before you begin your question.
Deirdre Desjardins with California Water Research. Rachel, I'm pleased to hear your presentation. I worked closely with Pacific Coast Federation of Fishermen's Association and provided testimony for them on climate change impacts in the water fix hearing. I was interested, I've been following President Biden had a directive about scientific integrity, and they've convened, the White House has convened a task force to look at restoring integrity to federal agencies. And I know there were many unfortunate things that happened under the last administration. I don't know if you're aware of the OSTP effort or how it's affecting how your agency proceeds, but I wanted to throw that out there and ask the question.
Yeah, thank you for that. One of the great things about, well, I should just say that I think it's on point to always kind of re-amplify the need for scientific integrity. And I would say that our agency with the National Weather Service under NOAA being a prime example where we had some challenges with kind of misinformation and kind of challenges around scientific integrity were very publicly visible. And so I think we have a lot of relationship building with the public on that front. From the government policy perspective, what I can offer to you is that as a scientist working for a federal agency, that policy around scientific integrity is not new. It actually was under the Obama administration, it was also active, and it actually allows me to sleep well at night. One of the things in the scientific integrity clause that's a federal law is that scientists speak for themselves, which I appreciate because I think our state colleagues, when I hear people, I feel like other entities have to feel like they have to talk for their agency. And I feel a lot of freedom in my own scientific way to communicate my own science and my own views. I hope to see kind of a better relationship building through the administration's re-emphasis and visibility on the need for scientific integrity to be able to gain public trust. And I appreciate you following that and kind of bringing that to the conversation. I think it's very important for the work that we do.
Okay, thanks. Any other public questions, Edmund?
There are none.
Okay, thanks everyone. We're scheduled for a coffee break. And so let's take we're scheduled for 15 minutes, but let's come back in 13 minutes at 10:20.
Thank you all.
Thank you, Rachel, for raising the issues that you did.
Sure.
Hi, Josh. If you're on, I'm not sure if you want to do a microphone check or a practice screen sharing on our break.
Sure. How's that sound?
Your microphone is working. Thank you.
Great.
We are recording and broadcasting, my friends.
Okay, welcome back, everyone. Our next panelist is Josh Israel, who is the Science Division Manager in the U.S. Bureau of Reclamation's Bay Delta office. He also provides support on managing the complex interagency and intergovernmental activities for the operation of coordinated state and federal facilities, as well as reclamation's restoration and recovery responsibilities. He's also been, as has Mike, one of the active participants in the DPIC effort to talk about rapid change in future science. So, Josh?
Hope you're on mute, Josh.
Can you hear me okay now?
Yes.
Great, just testing. Fantastic. Well, thank you for providing some time to share some perspectives, issues, and ideas we have about science here in the Central Valley and Bay Delta. I'm going to be talking really about some of the work going on in our science division in the Bay Delta office. I'd say typically I'm reviewing your reports and products and talking with my managers about sort of how they apply and translate to reclamation's work. So I really appreciate your interest in this opportunity to share with you the information and discussions I have with other reclamation managers regarding our science products and applications, and hope that this will be translational for you and useful for you thinking about the work that you do going forward. So hopefully you've seen the slide advance. I was going to talk a little bit about reclamation first. So the Bay Delta office is part of Reclamation's California Great Basin region. We operate, Reclamation operates in 17 states. This region has 5 area offices. That includes projects outside of the Central Valley, in the Klamath Basin, in the Lahontan Basin. But in the Central Valley, the structure is really unique in that while other reclamation water projects are all overseen by just a single office, because of the scale of the Central Valley project, there's actually 3 area offices that manage the facilities. The Central Valley Operations Office that manages water and power, and the Bay Delta office where I work that helps to manage our fish and wildlife obligations. Back when reclamation started, our initial charge was to develop the West, primarily through water supply to small family farmers and communities. You're probably familiar with our history, and in general, dams for water supplies are operated and maintained by reclamation, but there are dams across the West also that serve flood control purposes, and those tend to be operated and maintained by the Corps of Engineers. The American River project is unique in that it's jointly operated because it offers multiple purposes. We really recognize that the benefits of the hydropower generation at these projects can help us pay for water projects, and we provide surplus generation of power as a large part of our operation, but still in California,
I think you froze, Josh.
Yeah. Yeah, I think he's frozen. I'm sending him an email. Hi, Steve. Let's give Josh a minute. And then let me check to see if another presenter can go if we don't get Josh back. Does that work for you?
Sure.
Carl or Lenny, if you're on the line, can you let us know if you'll be ready to present early if Josh doesn't get back within a minute?
Sure, I can go up, but I don't mind nominating Carl either.
Okay, thanks, Lenny.
You can flip a coin, you know, virtually. But since you volunteered first, I'll let you go.
Looks like he's back.
Hi.
All right, welcome back.
All right. Let's get back to it. Let's make sure I picked the right screen. Okay. Hopefully you're seeing the screen. I was about to talk about Reclamation Bay Delta Office's Science Division. So the Bay Delta Office was created about 8 years ago, and we really focus on providing actionable and innovative science through collaborative planning, design, and implementation of special studies and monitoring. and helping to integrate fish and water management activities through synthesis and modeling. So one example I have here is a project that we worked on with Reclamation's Technical Service Center, which is our national laboratory, so to speak, in Denver. They have many, many work groups. This is a project where we do support a lot of habitat restoration in Central Valley Project tributaries in the Sacramento River as well under Keswick Dam. And this is a project where we looked at, designing habitat restoration projects and the fate of the gravel enhancement material in the end, so that we could not just maximize the benefit of the project, but also think through the frequency and duration of needing to do this project over time to support spawning Chinook salmon. Let's see. Moving on, a little bit of history on the Central Valley Project. The project was unique in that it's a federal project entirely contained within a single state, and originally was developed as a state water plan, but during the Great Depression, the state was not able to finance it, and Reclamation and the federal government stepped in. It remains a federal project because there really is a tremendous resource investment required, and it's very important to the nation. In the 1940s, many of the facilities were initially built, including Shasta Dam, Friant Dam down in the San Joaquin Valley, the Jones Pumping Plant, which is the Central Valley Project facility that exports water along the west side of the San Joaquin Valley from the Delta. And then in the mid-50s, Folsom Dam was constructed on the American River. In the early 60s, the Trinity Division was added to import water into the Central Valley Project from the Klamath Basin. In the 60s, additional south of Delta storage was built in the San Luis unit, and the State Water Project was brought online. And then finally, in the late 70s, the Stanislaus in the East Side Division was constructed. You may not be familiar with the operations, which is something we work on a daily, seasonal, and annual basis. So, there's a number of functions that we implement on a daily basis to operate these facilities. We really divert water to storage or for other beneficial uses when it's available. We release this water from storage for beneficial uses when water is not available. Beneficial uses include municipal and industrial needs, agricultural needs, fish and wildlife, and the allocation of this water for these purposes is in many ways controlled through regulatory permits, including those from the State Water Resource Control Board, as they're responsible for allocating water and protecting these beneficial uses. I'm sorry, I didn't move the slide on. The fish and wildlife responsibilities are primarily administered through the Bay Delta Water Quality Control Plan and the Federal Endangered Species Act that protects federally listed species. And then the contracts and agreements are administering the delivery of the Central Valley Project water. Ultimately, a lot of these things really come to a head in the Delta, where because of the Delta being the transfer spot between the reservoirs primarily to the north and the needs to the south, there is a need to support transferring water through there, and it's creates one of the challenges that we really need some of your assistance on. As you can see, the Central Valley Project is quite significant. It provides water supply to the majority of California's counties. 30% of the water for California's agriculture. It supports numerous wildlife refuges across the San Joaquin and Sacramento valleys. It also supplies water for close to 650,000 people. So one of the questions you asked was, how do we work with adaptive management? We're really focused in the working with other scientists from agencies and our own agency on creating reliable and credible science. And we try to do that by ensuring open, transparent, and innovative science. And we do that on a daily, seasonal, and annual basis with the other participants in the science enterprise. And we apply it to a number of different plans that we're implementing our CVP operations for. This includes the long-term operation of the Central Valley Project, which includes reclamation's proposed action in the NIMS and Fish and Wildlife Service biological opinions, the State Water Resource Control Board's water quality control plans, and then also the activities and the science that are going on through the restoration and research partnerships. Things such as the Central Valley Project Improvement Act's near-term restoration strategy, the Collaborative Science and Adaptive Management Program, and the Sacramento River Science Partnership. And a lot of our efforts are really focused on this idea. I call it probably adaptive management light, but it includes the most important parts, which are predicting, observing, and reporting what's going on. We try to work with others to improve predictions by what we're doing, and I'll showcase a little later, is some innovative modeling methods that leverage the engagement of scientists and managers to improve the effectiveness and the application of the results. With monitoring, we're really focused on what are the real performance measures we need to understand the balancing of the multiple purposes of fish, water, and power beneficial uses, and trying to understand how those performance measures are affected by the Central Valley Project operations and actions, and then trying to advance innovative observation networks and study designs to collect that information in the most effective way. And then with reporting, again, we're really focused on how can we accelerate evaluation of those performance measures to provide information at the right time steps for decision makers in the future, making sure that those science efforts are being done open and transparently, and then leveraging the current science data and visualization methods we have. So another thing we're really focused on, one of our goals is trying to support collaborative science partnerships. There's multiple purposes, and we have many purposes with our science too. This is a figure that I think Stephen showed right at the beginning of the meeting. We fund quite a bit of work to look at core science, status and trend science, synthesis, as well as targeted foundational and immediate research. And we do this by supporting the development of science plans, trying to fund those science plans priorities towards competitive science solicitation, and then really trying to engage scientists with managers and stakeholders to understand that information effectively. So another idea that we've had for quite a while is this idea of a collaboratory, and sort of getting beyond just the descriptive use of information, and trying to set up information so that it's open and transparently communicated through web-based services, and that data and science can be linked then to in-season management, to develop fisheries and water management tools. Just as an example, this is a project we have with the University of Washington called SACPAS. And these figures represent 25 years worth of daily flow and temperature data from Shasta Dam and from and flows in the Delta. And it just is shows you that we have a lot of environmental data, and we really would like to use these kinds of data sets as the information that you load into predictive and prescriptive tools to accelerate the information and make better predictions to support the information needs of managers who are thinking about flows in the Delta and temperatures at Shasta. Let's see. So I think I'm not going to go too in depth because I see some of my time's limited since I had some IT issues, but I think I'd like to walk through sort of 3 priority areas where science plans and the science action agenda have identified areas of interest related to our goals. And I'll try to showcase some of these through sharing some of the projects we fund and implement with other agencies. And then hopefully I'll have time to finish and share some of the ways that you may be able to help us improve our science going on related to those goals and the community's priorities and the cooperative implementation through the science enterprise. So structured decision-making and integrated models. We've been working with other agencies through the Central Valley Project improvement CVPIA for a number of years to develop decision support tools to improve our ability to predict and determine what action should we be taking annually and seasonally. These decision support models are very helpful because they link environmental drivers with the biological processes that affect species, and they can help us prioritize the actions to protect, restore, and maintain populations of the species that these decision support models capture. CVPIA has been working with an interagency team called the Science Integration Team for the last 5 years, trying to develop tools for fall, spring, and winter Chinook salmon, steelhead, as well as winter and green sturgeon. And they're using them to develop what they call policy plots. And this is an example of a policy plot on the right. And those 3 different shades of gray and black tell you 3 different types of actions you should do based on sort of the monthly survival and the rearing capacity of the population. So by looking at sort of the sensitivity of the biological responses of interest, and what we've focused on is juvenile productivity and adult returns for our efforts to use structured decision making, we can come up with what action should we be taking based on our observations surrounding survival, habitat use, and rearing habitat availability. We're also applying decision support models and integrated models to not just thinking about anadromous fish. We're also doing using these to think about the actions we're taking under the long-term operation of the Central Valley Project around a suite of actions called the summer-fall habitat actions for Delta smelt. In this case, we're linking some of our planning tools, DSM2 and CalSim, with higher resolution hydraulic models, and then feeding that information into bioenergetic tools and food web models and habitat models to look at if we take actions on the landscape in the Delta to support the food web and habitat, what is it really likely to do with biological outcomes like growth rates for Delta smelt, the abundance of Delta smelt, and food availability for Delta smelt. So another topic that we're working on that is of interest to a lot of folks, including, I know you've done quite a few reviews on this, is the monitoring enterprise. And we're really interested in advancing monitoring for fish and water management. We support a large array of fish surveys across the Delta. On the left-hand side here, you're seeing a figure of Fish and Wildlife Service surveys from their Red Bluff office and their Lodi office in the San Joaquin Valley, as well as the Stockton Department of Fish and Wildlife office, all being combined in one place to look at the distribution and presence and absence of, in this case, winter run Chinook salmon through all of the monitoring surveys in one place. This is really important because we have a number of real-time teams that meet on a weekly basis to evaluate the weekly fish monitoring data. And what they do is they come up with fish distribution estimates like the one you see on the right, and then they think about what operations are likely to occur over the following week in light of the fish distribution to think about risks to those fish populations. And so this is the case where we're trying to advance the visualization and translation of the monitoring surveys into real-time information, and it's actually proving pretty helpful. We'd really like to get this into a place to understand why we see certain trends, make it more diagnostic and also more predictive. And there is some nascent predictive capabilities on these websites that University of Washington has been developing for us as well. Next up is something that Rachel touched upon. We have an incredible acoustic telemetry program in the Central Valley that is operated and sort of coordinated through an interagency telemetry advisory group. We've been expanding the array of real-time receivers that allow us to bring information in real time. And this is just a figure of fish from two different release groups sort of moving through the Sacramento River. And you can see sort of there's two pulses. They were released at 2 times, so that's not surprising. But we've now started to set up these real-time receivers in a way that we can actually get real-time estimates of survival and route entrainment through the different routes in the Delta, like the Delta Cross Channel and the Georgiana Slough route into the Central Delta. And these kinds of performance measures used to be something that would take 2 years or 3 years for researchers to publish in peer-reviewed publications. And now we're able to derive estimates on a daily basis. And it's additional information that is helpful for coming up with these measures to inform folks with what's being observed or not observed when it comes to thinking about fish distribution and how that may or may not influence water operations in the Delta or in the rivers. So this is a fairly large program and something that we're seeing a lot of traction with. We're not just working, though, with trying to describe what's going on with fish. We're also interested in a lot of other constituents. On the left-hand side is a USGS demonstration project where we're looking at the cumulative nitrate fluxes and chlorophyll fluxes through a number of different regions of the Delta. We'd really like to understand how nutrients, primary productivity, secondary productivity, juvenile fish in abundance and productivity, and the community assemblage is characterized in different regions and different seasons and annually across the Central Valley and the Bay Delta. And we think that this will be very helpful for, really starting to diagnose the environmental drivers influencing these different environmental qualities like algal communities or harmful algal blooms. And it'll start to take it from being able to have real-time information coming in on these kinds of things. So then we can develop predictive and prescriptive tools potentially based on thinking through what are the real scenarios and capacities we have with either meteorology or hydrology. So I initially showed you sort of a simple adaptive management figure that showed you sort of how we try to make predictions, take observations in real time or seasonally or annually, and then put them into reports. And we now have a fairly substantial report series as part of our proposed action where we're developing seasonal reports on specific topics of mutual interest to the agencies, such as Shasta cold water pool management and Old and Middle River flow management, or in this case, is a topic that is a lot of interest. I mentioned earlier is this idea about the summer fall habitat actions. This is the adaptive management diagram in reality. This is an adaptive management diagram for our seasonal decision-making around summer fall habitat actions for Delta smelt. You can see it's a little bit more complicated than the simple model that we're able to implement in real time. But we're thinking that, we know that the Delta is a difficult place for active experimentation. That's because, there's difficult conditions for fish in the environment. There's potential impacts to water and power to consider, and there's also inflexible, in some cases, regulatory requirements that are required. So additionally, a lot of the tools for doing this work is very nascent, and there's a lot of uncertainty in them. And there is additionally variation around that uncertainty. And in many cases, because we haven't been doing the iterative process, it's not very well trusted. When action evaluations do occur, the reporting timeline is lengthy and doesn't always provide the information necessary to make the next informed choice. There really is, not clear agreement on what information is always necessary in real time, seasonally, or annually to inform the effectiveness of many of the habitat restoration, facility improvements, or other actions we're taking to compensate for project effects and contribute to the recovery enhancement of species. There's not full understanding amongst those in the field and working with the data about the importance of this information in many cases. And so your input on the value of information that's being generated by models or the monitoring programs, and in trying to help us understand if the right information is being collected, could be really helpful for managers and scientists engaged in studying these issues. So here's some of the things that we think about when we're thinking about how do we advance our monitoring programs, how do we integrate models better into supporting decisions, and how do we report effectively to communicate the science that will affect decisions. So, we're interested in understanding, are the operational parameters properly characterized that are being used in water operations and fisheries management? What is the value of habitat restoration, and can that be determined really? How can salmon and steelhead growth and survival be managed in the Delta? Are methods being used in studies likely to succeed and provide the information we need? And we really like to understand, are current water operations limiting fish recovery, or, to touch upon something that has been brought up, is it other environmental drivers that are affecting that? And how do we compensate and how do we address those? So this was, I think, the final question that Edmund posed to me to think about for you. How can the Delta ISB reviews and advice assist with your work? I would say, if you could help us understand what metrics may be available or developed to evaluate the effects of our actions, that kind of input could be very helpful to us. Where do the tools reasonably predict and observe effects of our actions, or do those tools need further development and improvement? Speaking sort of to this idea of distrust in science and the adaptive management process, and the difficulty of doing science and needing a safe space for science and experimentation in the Delta. When is our understanding sufficient, and when is additional study necessary? And then you all come from a diverse set of regions. So, are there alternative hypotheses and approaches that you're seeing are being used in your regions or on the same topics in your regions that we should be considering to improve management? So those are some of our thoughts on this. I don't know if I have any time left, but I'd always be keen to hear from any of you and look forward to talking more with you in the future.
Okay, thanks very much, Josh. Any questions? Let me start out with one then. Those are all very good ideas and suggestions, Josh. I'm wondering if you could put that in terms of sort of a science topic. Like when we think about our reviews, I think a lot of the information that you and others have provided have really, at least in my mind, helped us to understand the kind of content we should be thinking about within each of the reviews. But our reviews are often, at least historically, been topical, such as fish and flows and water supply reliability estimation and the monitoring and so forth. Are there sort of overall topics that you think would really benefit from a thorough review of the science in terms of, and particularly in terms of making recommendations of where the next steps in science ought to go in that field?
I'm glad you asked Rachel that same question, because it gave me a few extra minutes to think about it, Stephen. So one thing that I think would be very interesting and might be an interesting structure for thinking about ecosystem reviews is a lot of times you've focused on non-native communities or specific fish or specific models, but increasingly I've been thinking about the Central Valley and the Bay Delta and thinking about flows of energy and how, not only are there linkages between the aquatic and terrestrial ecosystem, but there's linkages between reservoirs and rivers, there's linkages between floodplains and rivers. We have a very broad monitoring enterprise that does a lot of research and status and trend monitoring on nutrients and zooplankton. And I don't know if the scale, if what's being measured is right, if the temporal and spatial scale is appropriate. And I think it would be interesting to think about holistically sort of this idea of, are we monitoring the food web and the flow of energy effectively? Because, there are a number of different approaches, whether they be environmental surrogates like dissolved oxygen, its relationship to smolt production, or, we taking actions that we think support the food web, but maybe not having fish in the environment to be able to measure the direct effect of fish very effectively. But thinking about those things, because we can model the bioenergetics of fish and think about how growth and survival are balancing out to result in higher production, resilient populations, because of variation in growth rates and variation in when fish leave places. So that might be a topic of interest, and it seems like we're funding a number of studies from reservoirs down into the Delta looking at that, but it's very, it's disconnected. They're not, I haven't seen a portfolio from reservoir to bay to think about the food web.
Thanks, Josh. Any other questions from the board members? Tom.
The other presenters all at one point emphasized climate change, but I noticed that was one topic that you didn't mention.
Well, I think climate change is something that is inherent, and we don't do a lot of research on it, although the Technical Service Center, which is our national lab, has produced in the past climate change assessments of all of Reclamation's water projects. There actually is one completed on the Central Valley project as well, but that tends to be done out of the national labs. It's not something that we're working on in the Bay Delta directly.
Okay.
Did we have time for another question, Steve?
Yes.
So Josh, thanks for that presentation. Very interesting, your description of the structured decision-making approach. But I'm also interested that you said there seemed to be a disconnect between kind of what decisions in the field versus this sort of modeling exercise that's going on separately. So I wonder, who's coordinating that? Is there any kind of common body that gets those people together, the field folks and the modeling folks?
We've been trying to do that through a lot of our contractual agreements. So making sure that what's being measured is in fact what we think is important. I think historically, there had been a lot of interagency discussion about that through programs like the Interagency Ecological program. Certainly, the Central Valley Project Improvement Act's science integration team took the approach of talking with the managers and finding out what do people think are important. They came up with these ideas of abundance and productivity, and then have now been working backwards to develop models to mechanistically explain those responses and tie that to management actions, and then also ensuring that the monitoring program that's measuring productivity and abundance of juvenile salmonids on tributaries is being enhanced and brought up to a level where they can quantify accurately and precisely that information so the models can perform better with better information in the future. I would say in the Bay Delta, the linkage between management action, performance measures and biological responses of interest to managers is not, and then trying to develop a monitoring program from that has not seemed as well coordinated.
Okay, thanks. Edmund, do we have any questions from the public?
Yeah, we have one from Deirdre Desjardins. Deirdre, your microphone has the ability to unmute. Please state your name and affiliation before providing your question.
Deirdre Desjardins with California Water Research. I was happy to hear your presentation. I'm wondering about the disconnect between the CVO, the operations, and the Bay Delta office, because it seems to me that one of the biggest issues is carryover storage and the ability of the Central Valley project that operates Shasta and Folsom, and they're two of the major reservoirs in the North State, to meet the Bay Delta water quality control plan requirements. And I don't know if there's any way that you're looking at that. I know there was a great deal of concern expressed by stakeholders, particularly salmon fishery advocates, about reclamation's change in carryover storage policies under the new long-term operations. But it also seems to be rather critical for adapting to climate change. Thank you.
Well, I can't speak too much to a disconnect between the Bay Delta office and the Central Valley operations office, because our biologists speak on a daily basis and weekly basis in coordinating with CVO, and there are almost weekly meetings of the various teams, that the interagency teams that are attended by both of our offices staff when that particular issue is what's being discussed. But I think the topic you're talking about of carryover storage is certainly an interesting one, where there's, I think, additional room for exploratory analysis, and in thinking about sort of, integrated models and how to support decisions about that. I think through what are the criteria that are used by folks who are not just thinking about fish, but also the other purposes of the Central Valley project associated with water and power. And how do those stakeholders and the managers that are making choices about power, water, and fish, what are their criteria? Is it end of September storage? Is it end of February storage? What is the, I think there is an interesting discussion that should happen across all of these different users of the Central Valley project about what's important to them and how can we quantify objectively what is important to them, and see if we can then start to unravel a little bit better what's feasible with different end of February or end of April or end of September storages in terms of those criteria. So then people have the information they need to make choices about those kinds of criteria or those kinds of operational targets or thresholds.
If I could make one follow-on comment, I did make comments on the long-term operations that it might be economically costly for permanent crop growers to have a kind of supply interruptions that they would have with really aggressive operations of Shasta that we've seen. I believe the EIS found that the average cost of water transfers would not be too high, but the problem is that in years like this, there have been massive curtailments and there actually isn't water available and they're having to take permanent crops out of production. So there may be a better economic spot, at least for those kinds of economic uses.
Okay, I think we're ready to move on then.
Thank you for a little extra time. I apologize for the IT
Oh, no problem.
problem.
No
Thank
problem.
you.
Our next panel presentation will be led by Lenny Grimaldo. He's the State Water Project Assistant Environmental Director for the California Department of Water Resources, and he's responsible for providing executive level coordination and policy guidance for the complex framework of environmental planning, permitting, and compliance activities associated with the permits for the long-term operations of State Water Project. Lenny?
Yes. Thank you for the introduction and thank you for the invite to be here today. I'm going to give a pretty general overview of the incidental take permit and then turn it over to my colleague, Dr. Eric Lobaczewski, to get into a few more details on the adaptive management plan. So if we could cue up the slides here.
Sorry, were you not seeing them?
I am.
Oh, okay.
Yeah. Are you going to put them in presentation mode?
Yes. Sorry,
Okay.
they thought they were. Just my computer being slow. 1 second. Does that look all right?
I don't see it in presentation mode yet, but we could,
All right.
I'm sure we can muddle through.
One. Sorry, you want to see the notes you're saying?
Oh no, Jenica, I think we were not seeing the slideshow mode. Oh, now we're seeing it.
There we go.
Okay. Yep. Sorry. One second. I was connected to a monitor and I think it was causing some issues. So. All right. How's that?
There we go. Okay. So next, we can move to the next slide. So I think I'll give a brief introduction of the incidental take permit, the ITP. It's a 10-year permit that covers 4 state listed species, the 2 smelts and the 2 Chinook salmon. And maybe I'll just take a quick pivot here because this might be a good point to interject that for climate change, I think for a lot of our activities, where we're pretty narrowly focused about those conditions of approval within the permit and how they need to be implemented in the 10 years, we're pretty focused on how those conditions get met. But for some of our bigger restoration planning activities, adaptive management, and activities that carry on beyond this permit, perhaps to the next ITP, we definitely have a focus on thinking about how we're going to deal with climate change, especially in some of the upstream tributaries and how we're evaluating some of the restoration. And I'll talk about that in a bit. And then maybe just as a more general overview, maybe 2 important points to highlight here for the ISB is that the ITP calls for significant investment in habitat restoration in the Delta. And as I just mentioned, some of the upstream tribs. And we also have a strong commitment to an adaptive management program and structured decision-making for a number of our conditions of approval. So we'll just give a high overview of some of those things, and then we'll give a little more details on how that adaptive management program is going to unfold over the next few years. Next slide. So real quick, this is the project area. It's basically from the Sacramento River, from the Feather River confluence, the Ice Street Bridge, the legal Delta, and Sassoon Marsh and Bay. And the permit covers our activities and our facilities within this area. Next slide. So one of the big areas of emphasis for the ITP are our real-time operations. Josh highlighted a few of those things that we're doing in concert with Reclamation and the federal fish agencies and CDFW. And this has taken a real good look on how we are managing protection of the smelts and salmons at the State Water Project and the Central Valley Project. For the ITP, obviously, we're focused on activities that we're doing as part of our conditions of approval for protection of the state listed species. So we have various conditions of approval that help provide that protection, including an early pulse protection when the rains first start and there's turbidity. And this is usually a period when we see high entrainment as fish start to move upstream. But also that's for the smelts, but there's also protections for salmonids as they begin to move downstream during these rain and turbidity events. So we're very focused on trying to protect the early onset of entrainment for these potential entrainment for these species. And then in addition to what may have been described by Josh in our shared BIOP commitments for protection of Delta smelt, we have additional longfin smelt protection measures as they are listed under the California Endangered Species Act. And then, of course, we have some similar conditions that signify the end of that entrainment risk period for both salmon and smelt. And in a nutshell, a lot of these triggers are prescriptive and hardwired. So, and they're based on many years of data and analysis, particularly some of the smelt triggers and the salmonid triggers. For longfin, we still have some emergent science that's being developed as part of our permit. But the long story short here is what we're trying to do is use the historical data to help drive predictions for when these risks happen in real time. And then we have these hard triggers that allow for that protection to happen. Next slide. So as I mentioned, the permit calls for mitigation for our project effects, and there's significant investment in this mitigation for our project effects. For starters, we carried over our 2008 biological opinion mitigation requirement of restoring 8,000 acres as part of the Fish and Wildlife Service BIOP, and this is for tidal marsh restoration that was targeted for Delta smelt. In addition, we carried over the longfin smelt acres from that permit. In addition, the ITP identified another 396.3 acres of tidal marsh habitat for us to restore as part of mitigation for some of our Barker Slough activities and just larger compensatory mitigation of the project. Next slide. An additional mitigation requirement is completion of the Yellow Notch project. This is I think one of the high profile, most important elements of our permit, and that we're gonna create increased floodplain habitat through the creation of a gated notch at Fremont Weir. And this will create habitat for a number of species, native species that use this corridor, the Yolo bypass, which you're probably aware of, during wetter conditions. So this doesn't, this includes species beyond the salmon, splittail, and sturgeon. So there's multiple benefits to be realized through this restoration project. And of course, there might even be some food web contributions for the smelts downstream from this project. Next slide. I think we've covered real-time operations, but maybe just a little bit more detail building off from what Josh was commenting on, was that we have a strong commitment to our work teams that help provide an assessment of risk for real-time operations. And this gets rolled up to a water operations management team, the WAMT, where there's plenty of discussion and deliberation about that risk. And in some cases, we're using pilot testing advanced statistical models to help understand what those risks are. And this assessment of risk and operation advice is provided up weekly that helps provide the operational decision for that week on how the project should be operated. Next slide. And of course, this is all done in close coordination within and outside the department. We have a very strong commitment and working on the science activities and our conditions of approval with CDFW, with the interagency ecological program. But we also have a strong commitment with working with the federal fish agencies, the state water contractors, and developing new science in a collaborative way that includes researchers from the universities, consultants, and other entities, especially for new science on Delta smelt, longfin smelt, food web research, and Chinook salmon. Next slide. We also have a strong commitment to the IEP long-term monitoring. This is the interagency ecological program. We have many elements of the IEP that are now mandated as part of our new ITP, as you can see listed to the right here. And what I really appreciate about the permit, that it gives us the flexibility to actually review and analyze the effectiveness of these surveys for determining whether they're meeting our objectives for our permit or other environmental objectives that maybe tie into our water resources control plan from the State Water Resources Control Board, or other activities that are happening on the horizon. Next slide. So as I mentioned, we have a strong commitment to science and monitoring. For salmon, maybe I'll just mention a few. Perhaps the most interesting and significant one is the 7.5.2. This is new and ongoing monitoring to develop a spring run juvenile production estimate, a JPE. And the concept here is that we have spring run that occur in a number of tribs in our Feather River. And we don't really have a robust monitoring program as is to determine if we're doing a good job in assessing population abundance and change. So what I'm excited about is this spring run JPE being developed in order for us to get a better handle on how the species is responding to not just our conditions of approval, but to the environment overall, including changes on the horizon, climate change, and any other activities that are happening out there. And through this process, it might be worthy to note that we're using a structured decision-making model effort to drive how that monitoring program will be set up and to evaluate the criteria for where we want to sample, how we want to sample, and eventually how this data would be used for project operations. Next slide. For the smelt, I think what I'll highlight here is 7.6.4, our Delta smelt summer habitat action. And this is our operations of the Susu marsh salinity control gates, the actions related to those activities and above, below normal and dry years. And what I'm excited about here is the ability to use structured decision-making again to determine the best ways for us to evaluate that information to help feed it probably into the next permit. That's probably my thinking here is, how would we change our prescriptive nature of this condition of approval to perhaps enhance something we may need further down the road. Or maybe we change it. Maybe we find that, in some years, there's other things that are more important drivers, and that's where we put emphasis on. But I think the nature of the structured decision-making process and inclusion of the Fish and Wildlife Service, CDFW, Reclamation, and the contractors, the state and federal contractors in this process is really driving a really good model for how we're going to learn and adapt from this action. Next slide. And then finally, I think I just want to highlight some of our longfin smelt science program activities. Something that I'm pretty excited about. Before coming into this role, I did a fair amount of research on longfin smelt. So it's a species near and dear to me. That may even be my hand there holding that longfin. But yeah, I think for us, we're interested in a number of things that we need to learn. Maybe what I'll highlight is perhaps the development of a life cycle model. I think this will be very important that we develop a model that I hope can be used to test different management alternatives, including some of our export restrictions, flow actions, etc. Next slide. And now I'll turn it over to Eric. And just as a quick bio, Eric is the State Water Project Policy and Science Advisor. And perhaps maybe I'll just call him the fixer for all my mistakes as I go along in this process. Turn it over to you, Eric.
Thanks, Lenny. Good morning, everyone. Thanks for having us here today. I'll just spend a few minutes touching on adaptive management as it relates to the ITP here. You know, I think we heard a lot from Josh on that touched on adaptive management, and Lenny kind of alluded to the adaptive management elements of the ITP as he walked through the earlier slides. So I'll just say that, you know, it's fairly unique to have a regulatory permit like this ITP that embodies or squarely points out adaptive management as key elements to a lot of the conditions of approval in the ITP. And so, you know, by my count, we're seeing upwards of 17 or so elements of the ITP that would be, you know, or clearly called out or identified as adaptive management in the ITP. And, you know, I put a finer point on that. So it's sort of like, what does that mean? Like, great, you have this condition of approval and it's subject to adaptive management. The way we're really looking at that is really depends on the condition, but we're really looking at cycling through the adaptive management wheel in front of us. You know, there's some variants of that wheel, even the more complicated figure that Josh showed earlier. But again, general idea is actually going through adaptive management as it relates to a lot of the items in the permit. And so we do that, we're looking to do that in a couple of ways. And probably first and foremost is pointing to these 4-year reviews that Lenny talked about and that are really important to some of the actions identified in the ITP that will give us a chance to set up the condition for evaluation in 4 years, understand what did we learn, what did we not learn, what is effective, what is more effective, what is less effective, give us an opportunity to actually adjust that action based upon what we've learned in, again, key point, in this regulatory setting. You know, we often think of adaptive management as it pertains to a project or scientific experiment. It's a little unique to see this ability for us to carry out adaptive management in that regulatory structure. So we're really looking forward to kind of test driving to see how we can actually make that work within this current term of the ITP, but also, you know, as we seek a new ITP, you know, after this 10-year term expires. Also add that when we talk about adaptive management, specifically for, you know, these various actions, we're going to have adaptive management plans, or we have adaptive management plans for those elements. And so pertains to, you know, Sassoon Marsh salinity control gates is a good example. That is a discrete standalone adaptive management plan for that action. Now that nests within this larger context of adaptive management, obviously for the ITP. So as we look at how well the salinity gate actions worked, what worked better, what was less effective, gives us an opportunity to adjust the salinity control gate action, but it lets us understand better, like, how did that salinity control gate action work in concert with all the other actions that are being taken of the ITP, and what, you know, where is some more emphasis we can put in the future on those actions to make them more effective. Just a little bit about the 4-year reviews. You know, this is something we're still developing how those will all be conducted. You know, we're looking at coordinating with reclamation on actions that both of our entities share. And so we don't want 2 standalone reviews for the same action. It seems like a recipe for a lot of confusion, if nothing else. Actions that are more specific to the ITP and the DWR, we'd be looking for talking about working through the Delta Science program to help us conduct those 4-year reviews. And lastly, I just kind of mentioned that setting ourselves up properly for those 4-year reviews, we've been working with in close coordination with the state water contractors, the small subset of individuals there, as well as Department of Fish and Wildlife, to really lay out 4 elements of ITP that are subject to adaptive management. What are some of our key questions? What are some of our key management questions? What are some of our key uncertainties? And what would be some of the performance metrics by which we could judge the effectiveness of those various actions? So again, you know, pointing back to the salinity control gates as an example, you know, laying out like, what are we really looking for that action to produce? And so when we go through a 4-year review on that action, we can chart ourselves towards answering questions and answering some of did that action actually perform to the degree that we were expecting it to? And if not, why? You know, and it gets a little bit of a loaded question, but it really helps us unpack, like, okay, we know we may not have all the science and understanding perfect from the beginning, but we will use these reviews, we will develop the science over the period of time that action is in play to chart ourselves best towards an understanding of the outcome of that action as it relates to the intended biological endpoint. Lastly, I'll just close out my spiel on adaptive management here. I'm kind of like a little indication of what we're currently doing here is, as like I said earlier, we're working with a small core team of folks to develop these we're calling them performance metrics broadly. And we'd be looking to kind of showcase that and share that once we have that developed and getting feedback from, you know, other key stakeholders. Kind of just end there. And Lenny, I think that kind of closes out our presentation. So I guess we can do questions.
Yep. Thanks, Eric.
Great. Thanks very much, Lenny and Eric, for your presentation and for joining us here today. I'll start off with one question, I think maybe for Lenny, is that you mentioned that food web research was one of the, you know, priority topics that you needed to look at. I think you called it a new science. That's come up in a variety of other discussions as well. What do you mean by, what do you need in the area of food web science?
Yeah, so there's sure, there's a few different layers here, but maybe I'll start with the first part is the restoration. We're committing a lot of dollars and effort to restoring tidal habitat. And obviously one of the biggest functions of that beyond the spawning and rearing habitat is the food web production and how well those sites perform. And we want to make sure that we have a strong effort through our partners there at CDFW, who's leading this research, that we understand how fish are responding to food web benefits that are anticipated through our tidal marsh activities. And I could let Carl speak to this perhaps during his presentation, but they're collecting a number of parameters that will help evaluate how well these sites are performing now and in the future. And some of these sites aren't online now, so I think what we're relying on is their evaluation of existing tidal marsh and shallow water habitats that will be helpful for us designing future projects. The second component of that is, for example, the Sassoon Marsh salinity control gate action, the summer fall habitat action. There's a food web subsidy component to that, where we have a hypothesis that additional flow coming down the YOLO bypass pathway may be used to augment subsidies for Delta smell. So that's just a couple to highlight. Maybe I'll just pause there, but yeah, no, it's a big focus for us and they're tied to our performance metrics, especially the latter, on how well we think these conditions of approval are performing.
Okay, thank you. Any other questions from board members?
Hi, Steve. I have a question.
Sure.
And I'm not sure if I'm going to phrase this correctly, but it's such a dynamic system hydrologically. And as I think about and how water's moved around, and I think about this weekly cycle of, informing and using adaptive management, at what time of the year do you really hold your breath and hope you make a good decision? You see what I'm saying? Are there these critical time points, and then yet that you really don't know, but you've got to make a decision and you just hope it works out? And how does that play in? Thanks for trying to understand my question.
Yeah, I think I do. And it's a daily struggle. So maybe I'll partition this out. So there are a number of conditions approval that are longer term implementation projects, like our summer habitat action, our marsh restoration, but maybe honing in on the real-time operations. What I would say is that we don't have the application truly of an adaptive management program for our real-time operations, but in the evaluation of how well we're performing, so we can go back and use models to assess, well, the model predicted you would entrain X amount of fish under this operation scenario. Is this how well did that model perform? So there's a constant validation of those models, or at least there should be, and we're working towards that. So one of our ITP measures is to develop, for example, winter run winter run entrainment prediction tool that allow us to assess how well we're doing on our daily operations. And we're pilot testing that, hopefully for full implementation in 1 or 2 years. But yeah, I think that's not adaptive management in the traditional sense of which we're talking about here, but it is a form of adaptive management, because we're going to continually assess the performance of that model for our real-time operation decision making.
Yeah, I'd add into that just that kind of closing out that adaptive management loop is if we do make a decision in any given year on a particular condition, that we make note of the hydro conditions in that year. It sounds rudimentary, but making sure we tabulate that type of information. So, in a subsequent year, it could be 20 years from now, we might see a similar hydrologic makeup, and then we would have something to be able to point back to that was like, oh, well, we did make that decision that one year, it worked well, so we'll go again type of thing. And that's where I see some bigger do loop of learning from this, even if it's more in the realm of these real-time conditions that Lenny was talking about.
Any other questions? Edmund, any public comment?
Yes, we have one from Deirdre. Deirdre,
Deirdre Desjardins with California Water Research. I just wanted to ask you, one of the biggest concerns I have is with in a third under the Coordinated Operations Agreement, which governs the requirements for release from storage to meet the Bay Delta Water Quality Plan. I believe in a critically dry year, the State Water Project has a 45% obligation, and that was increased. And in a third drier critically dry year, there's now no negotiated sharing. And I'm very concerned that next year could well be dry or critically dry, and there needs to be some kind of plan to meet the water quality plan requirements so that fish aren't clobbered. I don't know if there's any effort going on to think about that, but I wanted to ask.
Yeah, and I think you're asking if there's any effort or planning to assess potential species impacts. And what I would say is, with our partner over there with Reclamation and the fish agencies, through our dry year implementation team, and don't ask me what DRY stands for, it's an acronym that always escapes me, but through our dry year implementation team and through the ITP, we have a commitment to develop a toolkit for different things that we could do during droughts and drought periods. So that plan is available and posted monthly on our DWR website at the ITP webpage. And you can get a good sense of the flavor of the activities that we're planning for, including increased monitoring to see how fish respond during drought years. One of the problems we have with dry years is the water is really clear. So traditionally our nets may not be that effective. So we're making investments in environmental DNA. We're looking at other activities such as SAB monitoring, et cetera, to help provide an assessment on how fish will respond in dry years.
If I could clarify, I was actually asking if there was any effort to cooperatively work with Reclamation to have a defined sharing agreement next year, because it seems to me that if that isn't being planned, it could be rather disastrous.
Yes, we're in planning mode with Reclamation on a weekly basis for operations today, tomorrow, and in the future, especially given dry year conditions. And a lot of this planning and forecasting, once again, is provided through our drought contingency plan that's posted online.
Thank you.
Okay, thanks again, Lenny and Eric. Our final speaker or panelist for today is Carl Wilcox, who actually needs no introduction. He has a long, rich, and productive history in the Delta. He's currently a policy advisor for the Delta for the California Department of Fish and Wildlife, and has responsibilities in water planning and policy formulation related to the Delta. Carl?
Thank you, Steve. It's a pleasure to be here. I had really been looking forward to doing this in person, so I'm somewhat disappointed, but hopefully this works out. Are my slides being projected?
Yes. Sorry, Edmund, did you want me to go ahead?
Yes, please.
Okay.
Okay, great. So you can move to the next one. So the Department of Fish and Wildlife is the state trustee agency for fish and wildlife in California. And we're responsible for implementing the laws and regulations for fish and wildlife conservation. And fish and wildlife are defined very broadly under this to include not just what you would traditionally consider fish and wildlife, but plants and the habitats that they rely on and the environment that they rely on. The department I should have provided an organizational chart, but the department is made up of branches which provide overall policy guidance, and those are housed in Sacramento, and they're divided into two divisions. One that's focused on Fish and Wildlife Management, so a fisheries branch, wildlife management branch that are particularly focused on issues related to supporting hunting and fishing activities, as well as actual husbandry or conservation of particular species and the habitats that they rely on, and providing information, particularly to the Fish and Wildlife Commission, which sets many of the regulations that are responsible or govern how fish and wildlife are managed and harvested within the state. We also have an ecosystem conservation division, which is focused on habitat conservation planning. We have a water branch within that program that's focused and was created kind of in 2006 to really focus on water issues in California, particularly as they relate to the Central Valley and the state and federal water projects, but also, looking at issues on the North Coast with salmon management and water management. We work through the water branch closely with the State Water Resources Control Board and providing advice to them as they take their regulatory actions relative to water rights and those kinds of things. The overall policy guidance for the department is provided by the California Fish and Wildlife Fish and Game Commission. And it's been around since 1870. And it provides particularly approves all the regulations relative to hunting and fishing, as well as commercial fisheries, and also is responsible for making decisions regarding listing of species under the State Environmental or Endangered Species Act, referred to as CISA. And so their listing decisions, sorry about that, are guided by input from the department based on the best available science relative to the status of those species, the threats to those species. And as I think Lenny noted in his presentation, the state's list of endangered species isn't necessarily the same as the federal list. In this case of the state and federal water projects, we
lost you, Carl.
Steelhead are not state listed, but longfin smelt are state listed. So there are differences in regulation and how we look at those kinds of regulations and try to apply them. And in the case of CISA, it applies to the state project and not the federal project per se. Although much of the management decision-making is done in collaboration through the various teams that Josh described and Lenny referred to. I wanted to make a point that, in going back to Rachel's presentation and her diagram of spanning different aspects, the department, at least until more recently, has been on the right-hand side of that chart in managing and in the regulatory arena and in the planning arena, and relying on both its science, but the science of others to guide its management actions. So there's, you're starting to get to a place where there's a little bit difference in perspective. We're not primarily a science organization. We're a management organization. We manage in excess of 1 million acres of land within California. We also run grant programs that support both science, particularly through academia and through the agencies, as well as habitat restoration and statewide. and have been a grant managing organization since the CalFed days, particularly through the Ecosystem Restoration Program. And we're currently under Proposition 1. So we provide about $7 million a year in science funding for projects in the Delta. That funding is about to come to an end. But that has been a significant funding source. It is our priorities for the expenditure of those funds are guided significantly by the Science Action Agenda, as well as various agency and collaborative science priorities, and those are used to make our funding decisions. And grant criteria are made available as part of the solicitations every year. So those change based on priorities and focus of activities. The department also advises the Wildlife Conservation Board, which is an adjunct to the department, which is a significant funder of habitat restoration statewide, and particularly in the Central Valley as it relates to wildlife management and waterfowl conservation, and stream and habitat restoration, and high mountain meadow restoration more recently to address issues related to climate change and trying to improve and conserve habitat and make a more resilient environment. As I mentioned, we provide science we apply science internally and externally to produce, to support our decision-making processes, both regulatorily and for management purposes. And we incorporate adaptive.
Carl, it looks like you muted yourself.
Sorry about that. Next slide, please. I mentioned more recently the department has focused more on science. There was a period early on in our history where science was a major portion of the department's focus to guide management activities. That declined somewhat in the late 20th century. Partly due to the fact that the department is funded primarily by special fees, fishing licenses, hunting licenses, various forms of licenses, commercial fishing licenses, which somewhat restricted our ability to conduct independent science because of the restrictions and the focus of the activities that were consistent with that. Much of the work that we do that's science focused is similar to the Bureau or to the USGS and the Fisheries Science Center. So lots of it, particularly IEP, and much of our monitoring in the Sacramento and San Joaquin rivers is funded by reimbursable agreements, particularly with DWR and USBR. As is our involvement in the interagency ecological program. But in 2012, the department created, based on legislation, a science institute, which is focused on providing independent scientific guidance for research, monitoring, and assessment programs that support the Department and Fish and Game Commission's mission to conserve and manage the state's fish and wildlife resources, to assure that best available independent scientific information and advice is used to guide and inform the department and commission decisions, and in promoting and facilitating independent scientific peer review and promoting really science within the department by its employees and highlighting that and encouraging particularly publication and engagement in cooperative science efforts, and in promoting science-based adaptive management and ensuring scientific integrity and transparency in our decision making. Next slide. This is the mission. It's very similar to what I described previously, and has been the basis for formulation of a strategic plan that was recently completed for the Science Initiative or the Science Institute. And next slide, please. So, again, provide focus on the mission and then setting up two primary goals, one of helping to advance scientific capacity within the department, excellence and integrity and transparency, and also support and integrate California's initiatives on climate change, adaptation, and biodiversity. And the URL for the strategic plan is at the bottom of this slide. Next slide, please. As part of the same legislation that created the Institute, or the mandate for the Institute, the department also received policy guidance relative to focusing on ecosystem-based management as opposed to individual species. And this recognizes the need to look at the full array of interactions within an ecosystem and including humans. So really, as part of that, the department has brought on the social science capability to better involve and engage communities in the decision-making process and account for that, particularly in our regulatory actions. And then also focus on adaptive management, and which is incorporated into the department's programs as appropriate, and relying on the best available science. And the guidance document for how the department applies adaptive management is also available at the URL at the bottom of the slide. Next. Okay, so the department, much of our science program is involved, or science activities are involved in the Delta, particularly through the interagency ecological program. The department has an office in Stockton, through which we do run most of our scientific activities, primarily field work and laboratory work, looking at samples and evaluating the samples that we collect. This work is done in conjunction with the Bureau of Reclamation, DWR, who are the primary funders of our activities, and the Fish and Wildlife Service, National Marine Fisheries Service, State Water Resources Control Board, and USGS, who are let's say, the primary constituents of the IEP, through what's called the coordinators group, which is representatives from each of those agencies who work to coordinate science activities in the Delta conducted by the member agencies. Again, most of what we do is focused on the conduct of long-term monitoring activities, but also more recently focus on synthesis of the results of that work. The department leads synthesis efforts and modeling efforts within IP, but also works conjunctively with our partner agencies, particularly in the development of and use of our data in supporting life cycle model development. And then, as Lenny pointed out, the more recent focus on longfin smelt life cycle model development. The department also hosts the IEP website, and it's available at the URL on this slide. We also implement the fish restoration program, monitoring and program, which Lenny referred to. And this is tied to assessing the work, the habitat restoration work that's implemented as part of the 2009, 2008 BIOPS, and now currently under the ITP, so the 8,000 acre tidal habitat restoration requirements for Delta smelt and longfin smelt in particular. And that work is initially focused on the development of monitoring protocols and conceptual models for evaluating the results of those, which built on the DRERIP models that were developed way back in the CalFed days. And these are all conceptual models for assessing and guiding restoration activities and evaluating them. So that program, since we finally got projects online, is starting to collect data about the specific, outcomes of those restoration activities. And I would expect that, this will be a fertile area for potential review and synthesis as we go forward. I mentioned our granting programs. I won't touch on that anymore. Next slide, please. The department works closely in collaborative fora, and these have been mentioned previously by other presenters, but the Collaborative Science and Adaptive Management process, the Sacramento River Science Partnership, and the Central Valley Improvement Act restoration and science efforts. I think an important thing here is that, at least from our perspective, it's important to start being really clear about what the science plans are for particular issues. And consequently, the CSAMP process has developed a science framework for Delta smelt, although it's more focused on ambient conditions and really understanding the conditions that Delta smelt exist in and how those influence Delta smelt as opposed to just looking at the fish themselves. So it's more of an ecosystem-based look at how the system responds to various, or a framework for looking at how the system responds to both the ambient conditions, but the way that management actions are applied so that you're collecting consistent data in all years, not just related to a particular action. And this came out of the kind of problems that arose with the first adaptive management effort for the fall action in 2011, where there was a hurry up effort to put together a science program to collect information because it was a high flow event and the fall X2 requirement was in place. Recommendations came out of that for continued science and monitoring, and that got somewhat lost subsequently, and there wasn't a consistent application amongst years. So I think, an effort there is to really be consistent in the way information is collected and synthesized, and it's done in a consistent fashion in all years, so you can distinguish what the ambient conditions are from the management conditions. The Sacramento River Science Partnership has also developed a science plan that focuses, its activities. And similarly, through its structured decision-making process and its recently released science or restoration priorities document, the CVPIA is doing the same thing. Next slide.
You have about 1 minute left, Carl.
Okay. So the department's key scientific goals for science, collaborative development of science to define and address key management questions. So I think for us, it's really getting to what are the management questions so that you can formulate the science to address them. And what are the, we're constantly confronted with the issue of there's not enough, there's some kind of, we're not collecting the right information. Well, if we're not collecting the right information, what information or what questions aren't being answered or addressed or answered, and what additional information needs to be collected to address those management questions. And that, in my experience, since the early 2000s, that's always been the issue, is what is the management question at hand and what is the appropriate science to address that. Again, understanding the effects of climate change to guide future conservation actions. I think a lot of work's being done on that, particularly USGS's efforts and the Southwest Fisheries Science Center activities. And I think another thing to look at is how adaptive management is applied. There was a question to Eric and Lenny about that, and the differentiation between kind of real-time operations decision-making and adaptive management. I think as part of the ITP, there is an adaptive management program outlined. It's based on the adaptive management, more detailed adaptive management program that was included in the California Water Fix. And I think if you want to understand kind of how the elements of adaptive management and how it applies in various contexts, there's what's called the snowman diagram that was developed by Maria Ray in that differentiates adaptive management and how you look at real-time management, which isn't adaptive management, but you learn from what you've done in that as time goes by and through periodic reviews, and make appropriate adjustments, but you don't make those adjustments in any particular year. So we can go on to the next slide. Skip over this is just here to show relative to climate change that things have really changed, and we're probably going into a new series of where it's either of extremes of either dry or wet. Next, and we need to figure out how to deal with that. Important science issues coming up, again, climate change, application of adaptive management. I think another key thing is how we integrate. We've talked about structured decision making, but how do you integrate the Delta community or non-represented agency communities into that process to inform decision making or the direction of science and those kinds of things and the formulation of those questions. And I don't think that's something that we're doing. We made a first cut at it in doing something along those lines with the Frank's Track Reimagined effort, focusing on letting and working with the local community to drive kind of planning for that, but that wasn't science per se. So I think that's an open question of how the broader communities affected in the Delta are incorporated into how science is developed and interpreted. Next. I think the department has found science reviews by the ISB very helpful. I think the review of IP, many of the recommendations about what the IEP should be doing are being implemented, and so that has been helpful and reinforced those efforts. I think the recommendations about how IUP operates and how science operates goes to this broader question of science governance and how that is implemented, and the differences in the charges for what science is being done and who's making decisions about the science that's being done to meet their needs as opposed to the broader Delta science needs. So with that, I'll end my presentation. If there are any questions that relate to IEP in particular, Stephanie Fong's with me here and can answer those as well.
Thanks very much, Carl. Very informative. I really like this last slide here. Any questions from board members?
Diane and Laurel have their hand raised if you don't see it.
Okay, Diane.
Yes, I inferred from your presentation, Carl, which I really appreciated, that in the two of the bulleted items in the close to the end slides, you talked about effect of climate change, but then you moved on to emphasize the change in extremes, both wet and dry. And is that, and my impression is that you were emphasizing that over sort of the long-term change in the mean condition. Is that being driven by your concern about the basic survival of some of these endangered species?
Yeah, I think so. That, basically what we're seeing is what, people were forecasting. I think we're seeing it sooner than maybe we anticipated. And really, how do we manage species in light of the fact that we're going to be faced with extremes? And this goes to some of the issues that came up about reservoir management and temperature management below reservoirs, getting fish above dams into historic habitat where conditions are probably more resilient and don't rely on human intervention, as far as maintaining a temperature. So I think, it's the issue of kind of changing our focus and thinking about what life under more extreme conditions is going to look like.
Okay, Laurel Larson.
Yeah, thanks for the really informative presentation. And I'm just wondering what your thoughts are on the future of competitive funding mechanisms for CDFW now that Prop 1 is ending.
Well, they're gonna, these funding mechanisms have all been supported historically by bond funds. And in the absence, the department has never been particularly successful in getting general fund to support these kinds of activities. I think the science program has become, has started to get some general funding for that. Right now, with the end of Prop 1 money, and in the total volume of Prop 1 money, I can't even remember how big the bond issue was, but there was, I think, somewhere around $100 million available, or 80, someplace between 80 and 100. And so we've been, managing that to extend it over as long a period as possible, but that's about to run out. So I don't anticipate, unless there's another bond that specifies funding for science, and that was about $84 million out of, what was it, $7.5 billion, something along those lines, for science. So not very much, but that historically has been the way the department's been able to fund science as it relates to the Delta in particular.
Thank you, Carl.
So since we have time, I'm going to ask you a very unfair question, Carl. If someone put $10 million on the table for you and you had to give it to somebody to fill one scientific gap, is there one that comes to mind that's the best thing? It's the most important, urgent thing to do? You can take your agency hat off to answer.
Yeah. I think at this point, I think it would be a better assessment of the change in the Delta that we have seen in the last 10 to 12 years, and what the future is going to look like relative to that change and what we would do about that. I think, and this is, basically the fact that, it's become a totally novel system that's now, and I'm speaking of the Delta specifically and not including Sassoon or the lower bay part of the estuary, but it's become dominated by invasive weeds in particular and species that come along with them and like that type of habitat, to the detriment of salmon and the smelts in particular, just by sheer reduction in habitat and increase of things that compete and or eat them. And how do we move forward to reconcile the Delta to something that works better for native species, and not quite so well for, I think to some degree, that's what we were trying to do with the Frank's Track reimagined effort, and what we're trying to do and have tried to do through the idea of the Delta Conservation Framework for how we do particularly restoration or conservation planning in the Delta.
Okay, thanks. Edmund, any public comment on this one?
We do, but I did see Virginia's hand raised earlier.
Oh, okay, Virginia.
Sure. Carl, you and the others have done a magnificent job in giving these presentations, and as a fairly new member on the board, I really appreciate all of these talks. They've helped me tremendously. And you in particular have emphasized, as did others, adaptive management and the need to have that approach. And as you know, a key part of adaptive management is these conceptual models. And we've seen lots of conceptual models of the pieces, but I've yet to see one that kind of pulls the whole system together, which is really difficult, but for me is necessary to do an assessment like you just called for. Do you or some of the other earlier speakers know of any attempt to do that we may have missed?
Well, I don't know that there is.
Or is that
part of
useful?
the CalFed program, the DRERIP models were developed that were an attempt to develop conceptual models that addressed all of the aspects of the Delta ecosystem from a species to a habitat perspective. So, there's a tidal wetland component, there's a riparian conceptual model, there's a salmon, so there were conceptual models that were developed for all, and some recognition that, depending on the place and the issue, that different conceptual models applied in different places.
So we've seen some of those. Is there any attempt to try and put them all together? Is that just too
Not
complex?
currently that I'm aware of.
Okay, thank you.
It makes sense, but
would that be helpful, or is that just too complex and difficult to do, since it is always case specific?
Well, I think it goes back to the comment that Josh made about kind of the energetics of the system and how the system fits together. And I think potentially that is helpful. You know, some of it is gotten at with some of the life cycle models that are being done, but you know, they're again species focused and not necessarily getting at some of these more systematic elements and how they fit together to influence how the system operates and how we might make decisions about managing the system.
Thank you.
Any other board member questions? Okay, Edmund, you said public comment?
We have one from Deirdre. Deirdre, your microphone can be unmuted.
Yeah, thank you, Carl. Deirdre Desjardins with California Water Research. You know, Randy Baxter was the CDFW liaison to the interagency ecological programs, pelagic organism decline, management, analysis, and synthesis team. And they did produce a really good synthesis report in 2010 that went through all of the pod studies. I'm not aware of any current efforts to do that kind of ongoing synthesis. Is there?
Well, I think there have been a couple efforts with the MAST efforts and the recent flow MAST report or float MAST report that was just released within the last few weeks. Stephanie might be able to speak better to that, but there have been a couple. There was, you know, the original float MAST report that looked at 2011 and compared it with previous higher flow periods. I think one of the issues that we have is that, you know, the efforts have often focused on particular timeframes and maybe not the broader trends over time that the pod looked at and the pod synthesis.
If I could ask just one, you know, one of the key hypotheses of the 2010 pod synthesis report was that there had been a regime change in the Delta ecosystem, and the Delta Independent Science Board also did a white paper on that, and they weren't sure if it wasn't irreversible. I don't know, but it seemed a really important synthesis and a hypothesis.
Yeah, I think, you know, there's definitely been a change in the system, and particularly in relationship to how food web dynamics work and the role of invasives. I think, though, that there's a more recent publication out of UC Davis that kind of questioned some of the thinking around the regime change, particularly as it relates to particular fish species. So I think it's an open question, but certainly the system has changed.
Okay, well, thanks again, Carl. Well, I guess this concludes our panel discussion. I again want to thank each of the panelists for taking the time to come out and give us their presentations. As Virginia said this is exactly the type of information we wanted to hear. All of the presentations were right on target, and this will help us move forward in setting the stage for what our reviews will be like over the next few years. And we trust this is just the beginning of the dialogue, but it's really setting us forward, significantly forward. I think we will continue this discussion and topic in our September meeting, where Laurel Larson will give us these Delta Science Program perspective on this. And then we're setting aside some specific time to continue these discussions in terms of how we might move forward with our reviews. I agree also with Carl that it's unfortunate that we can't have this meeting face-to-face and spend more significant time in discussing and debating some of these issues, but hopefully we'll find time to do that down the road. So again, thank the panelists. I thank all the panelists, and I know it's a busy time, and we really appreciate your providing your insights to us. So I believe that ends this section, and we move on to preparation, item number 5, preparation for upcoming Delta meetings. And as all of you know, we're in this sort of a transition, potentially transitional stage, with maybe the our fate being discussed on Monday. But I also am encouraging board members now to start dreaming ahead of a new Delta, new Delta Science Board, reinvigorated and going back to our model of more lengthy meetings, and every second meeting being a face-to-face meeting, and really diving back into a set of new reviews. Hopefully that's not a nightmare to you all, but I think it's not unreasonable for you to start thinking about it a little more intently now. In September, we'll have a meeting that's going to continue this discussion, again, with the presentation by the science program. We will discuss in depth with the MER on the monitoring review and decide whether or not we're ready to go for a formal public input on that. And also talk a little bit more about the water supply reliability and see where we are with respect to any public comments we may have gotten by then, and getting your input on that. In October, we might have an action item related to water supply reliability, whether or not the report is completed, and have an action item on that. We're also thinking that we need to start reinvigorating our face-to-face meetings again. So barring, depending on how the future holds with respect to COVID and so forth, our initial thinking of planning would be to have our face-to-face meeting and a field trip in October, maybe another one in November or December. So getting back on that track of 6 face-to-face meetings per year. Anyway, so that's where we stand now. I think we'll wait to see what happens over the next few weeks, and then Edmund will be getting out to you all with trying to lock in our 2022 calendar dates and get those moving forward. Any questions or thoughts on upcoming meetings?
Just a simple thing, Steve. So to Tom's comment that he would like us to review the recommendations of the water supply reliability report, can we get a deadline of knowing when the right time, when our last moment is before that goes to public comment, and also make sure we have a copy of the most recent one?
Well, it's going to go to public comment. I think in the next few weeks, from what Edmund has said. I think if you, there's not a real deadline on it, other than sort of a month out. I think that's about when Jay and I'll look to wrap it up when we get the public comments. So if you could really focus on the executive summary and the recommendations, presumably we'll have a discussion at the next meeting about where we stand.
Yeah, I think it's being prepared right now for, for accessibility and so forth, and I don't know how long that'll take. And there's some other changes going into effect, I guess, by Jay and Tom in the next few days, just restructuring how they organize the some of that. But if you wanted to have enough comments into that are significant that might change those recommendations, the sooner the better on those. But there will be time after the public comments come in as well to make changes to the document.
Steve, do you mind if I provide a few comments?
Pardon?
Can I provide a few comments of suggested deadlines that might help Lisa a little bit?
Yeah, I just think to facilitate responses, you might send out like, this is the one that's going out to the public, some semi-final version, and just say, give us your comments in 2 weeks, just to help us make sure we stay timely.
Okay. Yeah. For the public comments one, if you want your comments to be considered, probably need them within like 2 business days. But if you want to provide it for the next version that's going to be discussed in October, that'll be like a month out. I'm not sure if that helps, Lisa.
Okay, that's all I had for that item. Any other questions from the board members? Any comments on future meetings? Okay, Edmund, you want to, item 6, what are our items for follow-up?
I just want to make sure you guys can hear me.
You're not as loud as normal, but I can hear you.
Okay.
Yeah, it's a little
I'll try to speak louder, but if not, I'll summarize it in my email, or just let me know if you guys can't hear me. So I guess our first follow-up item we just discussed is the water supply reliability review. Tom suggested that you guys focus on the exec summary. We'll send out the most recent version. If you want your comments to be considered before public comments, it goes out for public comments within 2 business days will be useful. Otherwise, like a month to review. That's our suggested timeline. For the monitoring enterprise review, the lead authors are preparing a draft for September for discussion on whether it's ready to go out for public comments. If you have written comments on any of the recommendations or best practices that were part of your meeting package, we would need them by August 25th for us to consider for the public version of the draft for September. In terms of meeting preparation, we're going to send out a doodle poll to see when we can do an in-person meeting between October and December. So keep a lookout on that. And then we're also going to start serving 2022 dates. And we're going to try to go back to the schedule of every other month if things go according to plan. Anything that I missed, Steve?
No, you may have mentioned it, but on the monitoring review, I think one of the questions is, in terms of the recommendations and best practices, any insight or thoughts you might have on the on whether they are targeted and specific enough.
All right, we'll capture that in our notes. Thank you, Steve.
Okay, thank you, Edmund. I think that concludes that. Our next item is public comments for matters not on the agenda.
We have one from Deirdre. Deirdre, your microphone has been unmuted.
I'd just like to provide some information about our ongoing advocacy campaign. We will be trying to, we do expect SB 821 to be passed by the Senate on Monday. And the next step will be the governor will have 12 days to either sign or veto the legislation. If it doesn't get a signature, it will still go into law. And then we do plan, there's a letter in your packet from Delta Counties Coalition. We're going to try and get another letter, and it's been a little bit held up by, we bought a new house and I've been a little bit busy with moving. And then afterwards, we are going to bird dog and try and make sure that your contracts are for, you know, a good number of hours as they were originally supposed to be. Very much, I cannot say enough. The Delta region is incredibly grateful to all of you for hanging in there. And I just think it's an exceptional act of professional dedication to stay on. And I just, again, I want to thank Steve for holding it all together. And he's just amazing. And so is Jay. So thank you.
Well, thank you, Deidre, for the kind words, and for the board. All the board members are terrific, and putting today almost 4-hour meeting together under our current circumstances, plus all the preparation. I really appreciate that too, and so thanks for your support, and we'll all keep our fingers crossed. So I think that concludes it, and the record can show we are adjourned 3 minutes ahead of schedule. So thanks, everybody. See you next time.